Good afternoon, everyone that has joined this call. We want to welcome you for this session. Thank you so much for joining in, and thank you so much for keeping around and being patient up to this time. Thank you so much for all the efforts you are putting in to ensure that the children receive information that children can be able to learn. In our today's seminar, we are looking at A-level mathematics, and today we are going to start with mainly paper 2. But before we start, I'm inviting a volunteer from any of the schools, but I can be specific, and I choose someone from St. Ponciano Ngondwe Kangulumira. Since I think you are one of the first schools I found online, St. Ponciano Ngondwe Kangulumira, can we have a volunteer student to lead us in a word of prayer? Any student from St. Ponciano Ngondwe to lead us in a word of prayer? St. Ponciano, you can unmute and then you lead us in a word of prayer. Okay. In case we are failing to get St. Ponciano, we can get someone from Archbishop Chwanuka Secondary School, Wichitov. Any volunteer from that school can lead us in a word of prayer.
Yes, thank you, Mr. Azim. I hope you can get us clearly.
Yes, we are very clear.
Thank you. This here is one of my students is going to lead us in an opening prayer.
In the name of the Father, and of the Son, and of the Holy Spirit. Lord Father, we thank you for the gift of life. We thank you for the gift of our parents and teachers. We pray that whatever we are going to discuss, that we may grasp it and understand everything. We pray and thank you in the mighty name of our Lord Jesus Christ. In the name of the Father, and of the Son, and of the Holy Spirit.
Amen. Okay, thank you so much for the word of prayer, and thank you so much, Archbishop Chwanuka Secondary School. So in today's seminar, like we communicated yesterday, we are going to mainly concentrate at paper 2, and in case time allows, we shall go on and look at also paper 1. But today, we shall give most of our time to paper 2 because it has also been noticed that children mainly spend a lot of time on paper 1. Like yesterday, teacher Fred shared with us. He told us that many students, whenever he moves around in Mbale SS, he finds that students are busy calculating pure instead of also looking at applied. And since we are looking for more of the engineers and other people within the mathematical world, we may need people who are going to be able to solve the real world problems. And therefore, today we shall have some concentration on paper 2. And therefore, you know very that when it comes to paper 2, we have what we call 3 major sections. And these 3 major sections are the ones that where you name sets the numbers that they usually bring for us. So the first section is the mechanics, then we have the numerical analysis, and then the last one is statistics and probability. So all the questions that come in the paper will always come from any of these 3 sections. However, when you are revising, you need to be now very careful such that you can be able to know how you should balance your time such that at the end of the day, you are able to score high. We know very well that when it comes to mathematics paper 2, we have numbers that are easy for every child, but we also have those numbers that are a bit tricky, that at times give us a bit of headache. And therefore, we want to help each one of us to be able to attempt such numbers. we know very well that when it comes to mechanics, you are going to be able to find 6 questions. When it comes to numerical analysis, it will have the 4 questions, and then statistics and probability will have 6 questions. However, you will need also to remember that not all these questions are set into one section. These questions are always balanced, meaning that if they are balanced, you must be able to choose wisely if you are to pass these numbers. So when it comes to mechanics, we shall always have the 3 numbers in section A. Then the rest of the 3 numbers will appear in section B. Meaning that for any person who is going to score an A or a distinction in paper 2, at least you need to do a number of set of mechanics. So that's why mechanics is really very important. At least know something in mechanics. More so now, one of the common numbers that have been coming recently, it was on Newtonian mechanics, where we had those kind of integration and differentiation of the different things. So you need at least to have a big idea on those. But also we understand very well that numerical analysis is very easy for all the children. So now for this one, you must be able to maximize that in case the number, because it is always going to be there. So meaning you must be able to maximize when it comes to numerical analysis, that for each number, at least you do make sure you maximize it for the best and such that you can be able to get A. Then statistics, we shall always find numbers on statistics and probability. So these are some of the things that we are going to be meeting. And in today's discussion, we are going to see how we can deal with all the 3. So I know some schools have prepared for mechanics, some schools have prepared for numerical analysis, and some schools have prepared for statistics and probability. So for each number of discussion, we shall try our best to see that at least we summarize the whole topic, like what we had yesterday, that at least we were able to summarize a lot when it came to statistics. So today we are going to run like that, and then we see where we can end. But we want to welcome all of you. Thank you so much for joining, and thank you so much for coming. I want to check which school wants to be the first to discuss today. In case you are ready, I want to check out whether Archbishop, you are ready to take us through the first presentation, or whether it is St. Ponciano Ngondwe. I'm also seeing St. Charles Rwanga Koboko, but also I'm seeing Popo Anak is also connecting. So any school that wants to be the first to lead us, or I'm seeing Samuel Opio. Yes, Teacher Opio. I don't know whether Anak is ready to be the first people to take us.
Hello.
Yes, Teacher Opio.
Yes. We need some few minutes to present. I think if there's any school where they can start.
Okay.
Yeah.
Okay. Okay, good.
Yeah. I'm still organizing.
Okay. Then let me check. Archbishop Chuanuka, are we ready?
You're just joining. It's not today.
Okay. Archbishop Chuanuka, are you ready? Okay. It seems Archbishop is not yet ready. Angola High School, are we ready? Ovla SS.
No, not yet ready.
Okay, not yet ready. For the meantime, I can run through the questions as we get someone to get ready to be the first to take us through the discussion. Okay, now when you look at our seminar questions, these are the seminar questions that we do have. And when you look at these seminar questions, we have arranged them like in mechanics. So meaning that we are going to have someone to come and discuss for us at least one of the questions. Yesterday, we were able to deal with some numbers, and some of the numbers that we were able to deal with, we were able to deal with the number on projectiles. We went ahead and also had, in fact, yesterday we dealt with only projectiles as the and then today I want us to look at also numerical analysis as one of the numbers to do. and then we can have a number in statistics and probability. Much as yesterday, at least we're able to look at 101 as one of the numbers, but I know there are other numbers within this that we can as well look at. So I kindly request you that look through the questions and then we choose which question we can start with, such that at least we are well represented in all the sections. But I also want to welcome Teacher Fred Nabohe. Thank you so much for joining. Yes, any school that is ready, in case we do not have, we shall. Okay. Yes, Teacher Fred, you can say something. Mwalimu Nabohe. Okay. I'm failing to get Mwalimu Nabohe Fred to say something before we dive deep into today's discussion, but I know he will be around to make some submissions in the course of the session. So I'm waiting for the first school that wants to present. I'm waiting for the first school that wants to present. The first school that wants to do the presentation. Okay, we'll give them a few minutes. So let's just be a bit patient and we see whether there is any school that wants to be the first to lead us into today's discussion. Any school that wants to be the first, kindly, the floor is open. The floor is open, but in case there is no any school, we are going to dive and we start on to our discussion. Okay, no school is ready. Okay, let me. Okay, Yitula S.6 is ready. Okay, Yitula, we can start.
Yeah, we are ready.
Okay. Okay, Yitula, we are good to start. Kindly go on.
Yeah, we are almost there, trying to put things right. I hope the video is seen there.
Yes, we can be able to see the video.
The audio is clear?
Yes, the audio is clear.
Okay. Yeah, just start. You present.
All right, my dear fellow mathematicians, you're most welcome for today's discussion. And my name is Corey Xavier, and I'll be taking you through question number 37. I hope most of you have the questions. And numbers 37A is telling us to simplify sine 105 degree minus sine of negative 15 degree divided by the cos of 105 degree plus. So we have sine 105 minus sine of 15 degree divided by, we have cos of 105 degree plus a cos of a negative 15 degree. All right, this sine here is negative 15 degree. So, my dear fellow mathematicians, what we do is we already see that this question is asking us to simplify. And here, sine of 105 is a very large value. So we can simplify it. So sine of 105 degree,
I want to, Itula, do we have any, Itula, I want to find out, do we have any paper 2 number?
No, it's not there. It is paper 1. I don't know. Maybe today is for paper 2 or.
Yes, today we are mainly wanted to look at paper 2.
Okay. It's okay. In case maybe there is any other school that's ready for paper 2, would also prepare and get one that would come for paper 2.
Okay. Okay, but let us continue as the other school gets ready.
Okay, thank you so much. So here, I already said that this angle sine 105 is a very large angle, so we can simplify it. So here, when we have our quadrants, we have four quadrants here, all students take chemistry. So this angle, I'm going to simplify it and have to be around here because this is 90. When I add on 15, it will be, so we are trying to simplify this 105 degree. So here, you know that sine is positive. So this sine of 105 is the same as cos of a negative 15. We're going to take this because here in this second quadrant, our cos is negative. So here, we are going to simplify this because when you press cos of negative 15, it's already the same as sine of 105. So this will be minus. We have our sine of negative 15 degree, which is divided by this cos of 105 is also a very large value. I'm going to simplify it. So, using the same quadrants, when you move on here and try to simplify 105, again, you reach to this extent. So you get here 15, but cos here is negative, okay, in this second quadrant. So when you press in your calculators, you will be the question to see that cos of 105 degree is the same as sine over 15 degrees, which is added to a cos of our 15 degree, which is negative. So from here, we're going to proceed. So dear mathematicians, this cos is of 15 negative degree, but cos of a negative angle is the same as cos of a positive angle. So here, what we shall do is, but already you can see that this negative has affected this negative outside, such that when it comes in, the whole thing will be positive here this side. So we shall have cos of 15, because this is already a positive angle, which is added to our sine of 15 degree. These are affected this. Yeah. So we're going to divide this by sine. This is negative, sorry. Because when you press up your calculators, you're going to get the sine of negative 15 the same as cos of 105. So this is sine of negative 15 degree plus cos of negative 15 degree. Okay, let's move on. So I'm going to arrange, because I already have sign here in this expression. So I'm going to bring this sign here, but cos of the negative angle is the same as cos of a positive angle. So we shall be having cos of 15 degree plus sine of 15 degree divided by this one. I'm going to bring it here such that we have cos of 15. But this angle here is negative. So when it comes here, it has affected this positive such that we have sine of 15 degree. Okay, let's move on. Now from here, you have to reflect back into what the question is telling us to do. The question is asking you to give your answer in a form, and that should always be in your mind. So what shall we do from here? Because what you can already see that at this step, you people is to obtain what tan when you divide through by cos of a 15 degree. So at this step, you shall be saying that dividing through by cos of 15 degree, we're going to divide all these terms by 15 degree, cos of 15 degrees. So here, I'm going to show it such that everyone understands what I'm trying to mean. Okay, from here, after dividing, I'll be always of course 15 degree divided by this, I'll be obtaining 1. Then plus this is already a tan of 40, tan of 15 degree, because we know that sine divided by cos is tan. So this is all divided by this, we have 1 minus, we obtain a tan of 15 after dividing this here. So from here, dear mathematicians, you can already see that you'll be reflecting back your compound angles, you'll be going to obtain something of a tan A plus B. Because this one, we have an innocent 1 here. So 1 is the same as 45 degrees. So here, we shall be having tan of 45 degrees plus tan of 15 degrees, we shall be dividing it by 1. But here, we should not also be putting what? Tan of 45. Because when we reflect back the expression of tan A plus B, we will be in position to obtain our 1 here, which is not in terms of a ratio, but a constant. So we shall have, but there is an innocent 1 here, fellow mathematicians. So this innocent 1 is the same as tan of 45 degrees. Then, not forgetting our tan of 15 degrees. So the other ones having this, you already know that it's coming from a tan A plus B. So let's move on. And here, you can already see that this is coming from this. So meaning that I'm going to take the whole of that as this plus B. But my A, meaning that my A is 45, then my B is 15. So there's no need for you to also put A and B. What you do is you simply add. You're going to say 45 degree plus 15 degree. So here you would be obtaining something of this kind. This would be tan of 60 degree. But here members are reflecting. You can already see that this 60 degree is a special angle. So tan of 60 is the same as root of 3. When you reflect back into your trigonometry, the intro. So, but the question is telling us to give our answer in the form A into root of 3. So we can finally conclude that therefore sine of 105 degree minus sine of a negative 15 degree divided by cos of 105 degree plus cos of negative 15 degree is the same is equals to root 3. Okay. From here, someone would be asking probably that where is our A coming from? There is that innocent 1 here. So simply we're going to also let our mathers know that our A is 1 because we have that 1 in front. Hence, this is the answer for this simplification. So that's question 8 of 37. We're moving on to question B. In case there is any question, please make sure you remind me at the end of this question. So we're moving on to question B. And question B is telling us that given that X is equal to tan theta minus sine theta, and Y is equal to tan theta plus sine theta. So the question is telling us that we should prove that x squared minus y squared, the whole thing squared, is equal to 16 xy. So here we don't need to put 16 xy because you've already shown the examiner that you've reached the answer after showing that is equal to 16 xy. Here we don't need to show that step. So we're going to consider our left-hand side such that we simplify out this and check out if our final destination is 16xy. So from here, dear fellow mathematicians, you're going to see that we shall be substituting these values of x and y. So here we shall have our x is squared, so but our x is tan theta minus sine theta. So okay, so this would be equal to tan theta and then minus sine theta. This is our x value, but it is squared. Okay, minus y is this value tan theta plus sine theta. But also, we are saying that it is square. But the whole of this expression is square. So what we do, we put some curly brackets and raise it to that power 2, the whole of this. So from here, dear learners, we're going to see that we shall be, okay, what have you observed? Here, you already see that this is the difference of 2 squares. Because I'm taking the whole of this to be my A, but square, then minus B, but square. So this is already a difference of 2 squares. So what should we do? We reflect back how we can express A squared minus B squared. So here, it's the same as tan theta minus sine theta, okay, plus, this is B. So plus tan theta plus sine theta. This is already the first expression, but multiplied by now the difference of A and B. Remember, this is our A, this is our B. So we are going to put our A as tan theta minus sine theta, but minus. So this negative is going to affect. So we have to create a bracket such that it does not confuse the other sides. So here we're going to insert our B, which is tan theta plus sine theta. So we're not forgetting our bracket, but square. So fellow mathematicians, this is a very simple expression. And what we're going to do is to collect like terms. We already see that tan theta plus tan theta gives us, it gives us 2 tan theta. Negative sine theta plus sine theta, this one already cancelled. So this is multiplied by what we get in from this second expression. So here we have tan theta. Now when we open out this bracket, we're going to see that it would be negative tan theta minus sine theta. So you can see that this tan theta is going to cancel with this tan theta, such that we have negative sine theta minus sine theta, such that we obtain some negative 2 sine theta. So this is the expression, but Don't forget your square outside this one. So what shall we do? We're going to simply open out this, maybe let me put these brackets for now. Okay, this negative, this 2 outside is affecting everything here. So, but we first have to deal with what is inside the what? The brackets. So 2, when we multiply this 2 times this negative 2, we have negative 4. Negative 4 squared is already 16. Are you see? So we're moving. And then we have our tan. It is also squared. We have our tan squared theta. And then sine squared is the same as sine squared theta. Okay. Let me know if there's nothing there. If there's any question, you can still ask. Okay. We are still going to continue. So we are at this stage now. Now, dear members, what the question is asking us to do is to get 16xy. But from here, I can easily simplify sine squared theta. Because if I simplify this one, I'm going to obtain sec squared. But I'm not interested in getting sec. What I will do is to just simplify this sine squared theta such that I have 16 tan theta into tan squared theta, sorry. Then tan squared theta. Then into, when we express this from our trig identity, it's the same as 1 minus cos squared theta. So, dear fellow mathematicians, we're going to open up this such that we have 16 tan squared. This time this is 16. I mean, this time this is tan squared theta. Then tan squared theta minus cos squared theta is the same as sine squared theta. I know some of you would have been developing some premonitions of seeing sine squared theta, but we know that tan squared theta is the same as sine squared theta over cos squared theta. When we multiply this by that, I will see that the cos squared theta cancel. We will be in position to get sine squared theta. That's to clear your doubts on how I got this sine squared theta. So let's move. Okay, so let's create these brackets such that we don't get confused along the way. But using a mathematical art, you can already see that this expression is a difference of 2 squared. Because when I reflect back our question, x was tan minus sine theta, tan theta minus sine theta, and then y was tan theta plus sine theta, meaning that this was got from difference of 2 squares, and here we already have difference of 2 squares. So we're going to have 16 into, okay, what shall we do? It will be tan theta, okay, minus sine theta, okay, into tan, this is how I expand this, tan theta plus sine theta. So, but we're going to let our markers know what's happening. But we know that tan theta minus sine theta is the same as, we come here, it is x. Also, our tan theta plus sine theta is the same as y. We are defining. So what shall we do? It's a product here. We're going to multiply this x and y such that we obtain 16, y. So therefore, we're going to finally conclude that x squared minus y squared is equals to 16xy as required. So that's the simple mathematics behind this question, and you already know that if you don't reach here, meaning that you have used another route, and that's making you nowhere. So let's move on to question. That is the part C. In case there is any question, I'll be ready to get it at the end
Before you wrap, before you wait to wrap, first wait. Oh,
Okay.
yes. There were some questions.
Okay.
Some people had questions. How did the cos 150 become sine 15?
Okay. Exactly. How did cos 100 cos 100?
I think it is 105, eh?
105, yeah. Become
Sine 15.
sine 15 or sine negative 15.
Yeah.
Okay. I think I tried to illustrate it in our quadrants. I said when this is our quadrant, we have 4 quadrants, okay? This is the first, the second, the third, and the fourth quadrant. So we are saying that cos of 105 is the same as sine of negative 15. So this is, we're going to simplify this 105 degree. So this 105, we are going to move from our quadrant. Then we see that this 100, 0.5 is lying around here. We know that this is 90. From here up to here is 90. So what are you left with? If you subtract 90 from 105, you're left with 15 degrees. But you always remember this mnemonic that all students take chemistry. So here, it's only sign that is what? Positive. It's only sign that is positive. But our cos is lying here also. Cos becomes negative in this second quadrant. So cos becomes negative, okay? Just put that in mind. Okay, so why we are saying 105 is the same as sine of negative 15 is because what you get in your calculator when you press 105. Someone should try pressing out 105. Cos 105.
Negative 0.
Let me know if you're also getting negative 0.2588. It's still continuing, right?
Yes.
All right. So when we press this cos of 105, we are getting negative 0.2588, okay? Meaning that our sign is here already, okay? Sign is here, it is positive when you press it. When you press, you know that in this second part now, sign is positive. But if you press a 105, your answer must be a negative, okay? Meaning that you have to introduce, though sign is a negative in this second part now, you have to introduce a negative sign because when you press sign of what? Of 15, it will give you a positive of this. But we need our 105, cos of 105 is negative. So meaning that you're going to also introduce negative to this angle of 15. Let me hope you have gotten my explanation.
Okay. Which answer did you get?
My answer. When I pressed cos of 105, I got negative 0.2588. It is still continuing.
Like the final answer.
The final answer.
Mm.
The final answer is root 3. Because that's the interest of the question, that your answer should be in the form of a root 3. But I did mention that there's an innocent 1. And already I think defined it somewhere that where a is 1. There's an innocent 1 here.
Okay. Fine,
Yeah.
it is fine. Let
Okay,
me hope now. Okay, I think I think schools have got it. It is fine.
Okay, thank you so much. We're moving to C part of the question. part of the question is asking us that if PQ and R are angles of a triangle, we are supposed to prove that 1 over P cos squared. We have our angle. So, dear fellow mathematicians, you have the papers, I believe. This, I'm going to use small P here, but this is an uppercase. So it is capital P over, this is the angle. So it must be capital. So plus 1 over Q cos squared. Our angle here is Q over 2 plus 1 over R cos squared R over 2. We're supposed to prove that this is equals to this open bracket P plus Q plus R, but the whole thing squared over 4PQR. Okay? But when we interpret this question, when we look at this question, we have unknowns here. And on the other side of at the right hand side, we also have unknowns, meaning that we are not going to let, okay? We are not going to consider a site. So what you do is to interpret, and when you use a mathematical eye, you can already see that this question would not be easy to tackle, but you need to have the aspect of, you need to know how to use our cosine rule. Because now here, we are saying that PQR are the angles of the triangle, meaning that this PQR, these are the angles. So this PQR, the lower cases, meaning that these are the sides. So we are going to use our cosine rule for this case. So meaning that what I'm going to do is I'm going to have P squared. This is from the cosine rule. P squared is equal to R squared plus Q squared minus 2QR cos of P. This is the upper case, okay? All right, that is one. We can also derive another one. We shall have Q squared is equal to P squared. All right. Okay. All right. Okay, from here, it's okay. Let me try to now speed down, okay? Because some of you, I'm seeing that already complaints, so let me try to slow down. So I said that we are going to use cosine rule because this question we may not easily deal with without using our cosine rule. So from cosine rule, we are going to get P, R, P, Q, and R in terms of cosine rule. So we already got P squared plus R squared plus Q minus 2QR cos P. Then the same for Q squared. So it's as you having R squared minus 2PR, but our angle is Q. So that's what we shall be having. We are going to repeat it for R squared for this side, for this other side of the triangle, such that we obtain P squared plus Q squared minus 2PQ, okay? Cos of R. These are the three expressions that we can get from the sides of the triangle. We have three sides of triangle R, P, Q, okay? So using cosine rule, we can obtain these sides as we already gotten it. So now let's move. From here, when we look at the question, we already have an addition of these angles from the left hand side. So what we are also going to do is to add up all these sides of the triangle, such that when we put a positive here, when we add up all these sides of the triangle, we equate it to the other side. So this plus this plus this shall be equation to obtain P squared plus Q squared plus R squared. This would be equal to, okay? Now, I'm going to start with P, because if given here, the order is P, Q, R. So from here, we can already see that there are 2P squared. So when we add up, it would be 2P squared plus, moving to Q, there is P squared, P squared. When we add up, we shall have 2Q squared. We also have 2R squared. So plus 2R squared. Now, you can see that even though when we add up all these ones, because of the negative and positive, we shall still obtain negative 2QR. The cos of this angle, this is uppercase. Then minus this is 2 PR cos of P. Sorry. Then we finally put on this 2P Q cos of R. Okay, let's move. Now from here, you can already see that we have like terms. We have P squared, we have P squared this side, P squared here, we have P squared this side. Meaning that what I'm going to do is, because the angles, these angles are in the left-hand side, I'm going to bring all these ones to the left-hand side, such that I have 2 QR cos of what? P. This is an uppercase P. Let me hope you will be able to distinguish, because this is a small P. So the moment you extend something here, you're showing the examiner that's already a small P. So plus, we bring up all those ones to PR cos of Q. Okay? Plus 2 PQ cos of R. All right. Now, when we strip this one, when we move this one to the right-hand side, stripping this one to the other side, we shall obtain 2P squared minus a P squared. So equals, I'm taking this one to that side. We shall have P squared plus, taking this Q squared to the other side, you subtract away from this 2Q squared, such that I have a Q squared. Then also taking this one to the other side, will be subtracted away from this 2R squared, such that I have R squared. Okay, let's move. Now from here, you can already see that in the question, we have the angles from the left-hand side. Then, at the end of the question, we have P, Q, R, but we are still not going to reach there. Let's move on slowly. Now, from here, you can see that in the question, we have 1 over P. But here, we have 2P R in front of cos of P. So what shall we do then to obtain 1 over P? So what we shall simply do is to divide dividing through by 2P QR. I can have a side work here such that some of us get what we are trying to mean. So this is 2Q R. Okay. This is 2QR. We are dividing the whole of this expression by 2 QR. So this is 2QR over, we have 2PQR. You can already see that these 2 and this cancels, this one and this cancels, and this cancel. What are we left with? 1 over P. There we go. This would be 1 over P. Okay? 1 over P cos of P uppercase plus, again, we divide on that, we shall be obtaining 1 over 2 cos of Q. Okay? So this is just the same from you're going to use the same illustration over 2 P Q R. Okay. You're going to have 1 over 2. All right. Plus 1 over R cos of R is equal to, also this other side, we're going to divide it by 2 P Q R. All right. This will be 2P squared plus Q squared plus R squared all over 2P Q R. All right. Let's proceed. Okay. Sorry for that inconvenience. We are proceeding. But when we reflect back to our question, in the left-hand side, we are having our angle reduced. It's already a half angle, but this cos here was squared. So what shall we do? We are going to reflect our double angle. I'm going to illustrate it and see how we obtain 1 over p cos squared p over 2 as an angle. So we're going to say, but cos 2p is equal to 2 cos squared p minus 1. All right. But we are interested in getting cos p, meaning that we shall divide the angle by 2. Okay. So here, dividing the angle by 2 shall have cos p equals to 2 cos squared p over, let me say this is p uppercase minus 1. All right. That is how we obtain the p over 2 from that this double angle. So meaning that we're going to substitute this cos of p with the whole of this. And that's what we shall also do for the rest of this, but being considerate of the angle. All right. So 1 over p, we're going to substitute it with this such that it's 2 cos squared p over 2 minus 1. We close our bracket. Plus, all right, this is 1 over q into, because the angle is q, we're going to say 2 cos squared q over 2 minus 1. But close the bracket. Plus 1 over r into 2 cos squared r over 2. All right. Minus, don't forget to put your 1. But the whole of this is equal to p squared plus qr squared plus r squared all over the 2 p q r. So don't forget to tell the examiner that you're implying that this is equal to that. All right. And that's the same thing with that between. This implies that. Okay. So from here, we're going to open up these brackets. Okay. Such that when I multiply this by this, I obtain 1 over p. This time this p2, sorry, cos squared the angle over 2 minus this times this will be 1 over P. All right, we're also opening up this. This would be 2 over Q cos squared. Then our Q over 2. This and this should be minus 1 over Q. All right, plus this multiplied by this is I have 2 over R cos squared into R over 2. This but multiplied by this is I have 1 over R equals to P squared plus Q squared plus R squared all over 2PQ R. All right. Now, what do we see? We're already obtaining the angle in terms of half angle. So, from here, when you reflect back to our question, we're not interested in getting this one here, 1 over Q, and also 1 over R. So what shall we do then? We're going to move on all these ones to the right-hand side. All right. It's a P having. So this implies that 2 over P cos squared P over 2 plus 2 over Q cos squared P over 2. We're moving on that side plus 2 over R cos squared R over 2 equals to, we have our P squared this side plus Q squared plus R squared all over 2PQR. Remember, we are moving all these ones here, so it will change to positive. 1 over P plus 1 over R, I mean Q plus 1 over R. All right. Now, it's good to work out this right-hand side because we still have to this side, but in the question, we want to deal with that too. But let's first work on with our right-hand side. So this implies that 2 over P cos squared P over 2 plus 2 over Q. We have Q over 2 plus 2 over R cos 2 R over 2. Simple. Okay. Now from here you can already see that the LCM for this and that is 2P Q R. Getting the LCM of these denominators to be 2P Q R. When I divide that, I will still obtain P squared plus Q squared plus R squared. And then this, when you divide this 2PQR by this, which I have this one, when you divide this 2PQR by this, which I obtain 2QR, because the P will cancel, plus this divided by that, which I obtain 2, the Q will cancel, such that you obtain 2PR, plus this divided by that, the R will cancel, such that you obtain 2PQ. All right. But using a mathematical eye from here, you can simply see that this expression is coming from P plus Q squared, P plus Q plus R, the whole thing squared. We're going to explain that, but before we go there, let's first remove our 2. All right. So when we remove these 2, it implies that we have to divide the whole of this by 2, even including this term. So, meaning that when we divide this by 2, it's available 1 over P cos squared P plus this divided by 2, we shall have 1 over Q cos squared Q over 2 plus 1 over R cos 2 P over 2. So this is R. All right. Remember, this other expression in this side is divided by 2, meaning that we shall have something of this kind times 1 over 2, which when multiplied by this, we shall be in position to obtain our 4 as required in the question. But I did tell you that when you use an observant eye or mathematical eye, the whole of this expression is coming from this. So we are going to consider this P plus Q as our A. And then this R will be our B. Then you can either use Pascal's triangle, but this one is just obvious. So meaning that when we use our Pascal's triangle, we shall have P plus Q. The all of this was square. This is our A term. Plus we have our 2A, which is P plus Q. Remember, our Pascal was like this. So, when you move on, the power of A will just keep on decreasing. So this is A. So multiplied by B. What is our B? Is R. The power of R will be increasing. So this is already 2. No, it's R. Okay, this one will be 2. Because our R is B, we are trying to just see that. Okay. That's R squared. This is square. Okay. I was trying to get to expand this expression using our binomial. So I think this is our A and this is our B. So meaning that the first term will be our A. Okay? But because it is to the degree 2, we are going to square it. Plus, there is a coefficient here, which is for A, B. Our A is this. Then our B is this. R. Is here. R. Yeah. Then plus our B, which is our square. So when we expand this, what shall we get? P plus Q, we shall get P square plus 2P Q plus Q square. Okay? Then plus, all right, this is 2. When you open up this, you'll be 2P plus 2P around plus, because these 2 multiplied by P is 2P, but there's an arrow here, meaning that it is wise for us to put this arrow here such that we don't get confused along the way. So this 2 arrow multiplied by this shall be obtained into arrow Q plus our arrow square. When we rearrange this, we're going to get P square plus there is Q square plus there is R square plus, remember there is 2QR, so there is 2QR, 2QR. All right, plus there's also 2PQ, 2PQ plus there's 2PR. That was briefly to explain how the whole of this can be written as this, okay? So meaning that we can remove this other bracket there. So equals, we are going to have P plus Q plus R, the whole thing squared. All over, remember these 2 that was being divided through is going to change. The reciprocal will be 1 over 2, which will multiply these two PQR such that you obtain 4 PQR. And I think that's what the question demands us to do. So as required. Okay. So in case there is any question where there is need for help.
Thank you so much, Yetula SS. Let me hope the children online, you can be able to see the working. It is a length question, meaning that it needs you to prepare very well and to be well conversant with the trigonometric identities. So please, that was the question. Make sure that you can go back and then look at it. Thank you so much, Itula SS. We are going to go on to our other things, but thank you so much. It was a wonderful discussion from Itula SS.
You're welcome, Mr. Kaziva. Maybe to inform the people around who are in this seminar, Itula SS is one of the refugee host community school in Obongi district. It is hosting refugees from South Sudan. So the person who has just presented is called Corey Xavier, and is one of the internationals from South Sudan. That's what I just wanted to tell everyone.
Okay, thank you so much. That is good to hear that we have had some international students discussing for us. Thank you so much. Maybe for that particular number, there is a number he did for us. Schools, do not worry, you can have the second option. Because that particular number he has done for us, you could as well approach it in another way. Those people were asking, how was he getting this and this? The number that was like this sign of 105 minus sign of negative 15 out of cos of 105 plus cos of negative 15. Now, those schools that want, you can as well approach this number using the factor formula. You know very well that under the factor formula, when I have sine of A plus sine of B, when you have something like this, you know very well that this one is going to yield for us 2 sine of A plus B out of 2 cos of A minus B out of 2. But when you look at our signs or what we have, you can easily notice that this was a minus, meaning that now for that particular one, I'll say that sine of A minus sine of B is the same as 2 cos of A plus B out of 2 sine of A minus B out of 2. And this, since this is cos, I can say that cos of A plus cos of B is the same as 2 cos of A plus B out of 2, and then cos of A minus B out of 2. Then when you reach this step, you just follow the steps and say, now, since it is minus sign, I'll use the factor formula by saying that this is the same as 2 cos 105 plus negative 15 out of 2. Then I'll have sine of 105 minus negative 15, everything out of 2, divide by, here I'll have 2 cos of 105 plus negative 15 out of 2, and then I'll have cos of 105 minus negative 15 out of 2. So for this case, our A is 105 and our B is negative 15. So now when you simplify, cos 105 minus 15 divided by 2, you're going to find yourself that here you are going to remain with the 2 cos of 45. 105 minus 15, that is around 90. Divide by 2, you get 45. And then here you have sine 105 minus negative 15 is the same as 120. and 120 divided by 2 gives us 60. So you'll have sine of 60 out of 2 cos of 45. Then you'll have cos of 60. So when you reach this step, you can easily notice that some of them cancel. These 2 and the 2 can reduce. Cos of 45 and cos of 45 will reduce, meaning that you are going to remain with sine of 60 out of cos of 60. And therefore, it means that sine 60 out of cos of 60 is the same as your tan of 60. But we know very well that when it comes to 60, 60 is a special angle, and therefore we use what we call an equilateral triangle. So you can say that this side be 2, 2, 2, and we know that in an equilateral triangle, all angles are the same, equal. So this is 60 and this is 60. So if you want, it's not a must that you must use 2, 2 as your side. You can use even unknown A, 1, 1, 1, as long as you have labeled your sides the same. And therefore, we know very well that when I divide, this one will give me 1 and 1. And therefore, around this height will be root of 3, because now you have your special triangle where you have 1, 2, and when you use your Pythagoras theorem, you'll end up with that. And therefore, when you come here, we know that tan of 60 is always given by the opposite out of adjacent, meaning you have root 3 out of 1, which will give us root of 3, meaning that tan of 60 is the same as root 3. And the question had asked you to express it like that. Therefore, you can conclude that your A is the 1. So that is the alternative approach that you could use for such a number. Okay, so that's something that I wanted to bring to your attention. Okay. Yes, Hassan Waswa?
Okay, my concern is.
Oh, okay. Hassan Waswa?
Hello.
Yes.
I'm asking that since I have this sign minus sign of negative 15, can I bring out this negative to come and meet this negative so that I can have sign of say A, then plus sign of that 15? Can that factor formula still be applicable in that format?
Yes, that one is okay. But now when you bring such, it means that now you are going to use this one here of sine A plus sine of B. Because you know very well. Okay, you can first unmute. Yes, you know very well that when it comes to sine of a negative number, let me say negative theta is the same as negative sine of theta. So you factoring out the negative here means that this one will turn into positive. So you'll have something like sine 105 plus sine 15. For such a case, it means that you are going to use this identity. You are going to use this factor formula. So, but it is also very fine. Okay. Okay, so thank you. Thank you. So that is the alternative. Okay. Thank you so much, Itula SS. Now next, can we have, we are going to paper 2 only. So any school coming on, we are only doing paper 2. So next, we are going to have we are going to have Archbishop. Archbishop. Okay. Archbishop, you can unmute.
Kaziba TV.
We are requesting to share our screen.
Yes, you can go on. Archbishop, you can go on.
Yes, so this one here is presenting number 86.
Afternoon, everyone. I'm Kato George Tebandeke to take you through number 86. Number 86 is number 86. The question reads, given below are parts of a flowchart not arranged in order. Then part A is telling us to rearrange. Part A is telling us to rearrange. Before, if this they have given us our work of us that when we are drawing, use a ruler, then we have to indicate the arrows, and then you have to know what comes first. And as they have given us our question, we have to start with this. We have to start with this oval-shaped shape with skirt, as you are seeing here. Then after
we are not seeing the screen. We are not seeing the screen.
then as we have said, as you are drawing a flowchart, you have to use, first of all, you have to use a ruler. Then you indicate the arrows. Then you have to know what comes first as you are drawing a flowchart. And according to the question, they gave us our flowchart. Then we had to start with that oval-shaped shape, starting with start. Then after we follow the procedure. According to the procedure, we have to add on other as you see, we have the start. We have here the start. The start shape, the oval-shaped shape. Then you have to indicate this n equals 0. Then after putting the n equals to 0, you have to put in these values that the flowchart reads. Then after putting there, don't forget to put on the arrows. We are starting with the oval-shaped shape with the start. We go on, we put n equals 0. Then after, we put on this parallelogram with the figures that the flowchart is going to read. Then after, we put in this rectangle with the formula. Remember this formula they have given us in the question. Then after, we put in the vector, this magnitude of xn plus 1 minus x is less than or equal to 12. Then here after, you have to choose either yes or no. If it is no, you go. If it is no, you take this route. You use you put in this rectangular shape, n equals 1 plus n equals n plus 1. Then you follow the arrow, and if it is yes, you have to follow this route. You print this n, and xn plus 1 as they told us in the question. Then after, you conclude by the stop. Then part B was telling us to perform a dry run. The question reads, using n equals 44, x naught equals 2, perform a dry run of your arranged flow chart. Then, as you are drawing a dry run, you have to consider these values they have given you in the question. As we are seeing here, instead of n, we are going to put instead of n, we are going to put 44. Then instead of x, we are going to substitute with the two they have given us. Then after, you draw a table. The table must have the n, then xn, then xn plus 1. Then you get the magnitude of the difference. Then, when n is 0, x equals 2. But here, we are going to consider 4 decimal places. Then, you put in the formula. When you put in the formula, you write your formula in the calculator. Then, you substitute with x with 2. When you put in the formula, you are going to get this value. Then, for me, I took 4 decimal places. Then after, you get the difference. Then after, you go to n equals 1. If the value you got here is the value you put here. Then after, you replace that value with, you replace x with this value. Then after putting in x, you are going to get this value. Then the value that you get here is the value that you are going to put here. Then you do the same here, and you are going to get this answer until you get when the values are not changing or when they are constant. Then you will get the magnitude is 0. When you get the magnitude when the magnitude is 0, then you end there. Then part C was telling us, part C was telling us, state the purpose of the flowchart. Then the purpose of the flowchart. Then before you go to part C, they told you have to indicate the X that you have selected. According to our table, we are going to take 2.5755 as our X. Then we already have N as 44. Then they told us to find the purpose of the flowchart. The purpose of the flowchart is to find the fourth root of n. How do you see that this is the fourth root of n? According to the formula we have, here in the question, we are seeing that to get this formula, all of us, we know that we have to first differentiate. We have to first differentiate we have to first differentiate. Then this derivative, this one, as you are seeing here, you have to first differentiate. This the derivative of x cubed. It might have been x power 4. That is the reason why I am selecting to be the fourth root of n. That's what I had for you. Thank you for listening.
Okay, thank you so much. Archbishop, do we have some questions? Okay, now go back to the flow chart. Now, when you look at your flow chart, when you look at that decision box, always, if possible, make sure you draw a bigger one such that you can be in position to write the inequality along one line, such that you don't break it to have it at two different lines. Yes, that point. So make sure that your decision box is long enough for you to be able to accommodate. But also allow me to share something. Let me share my screen briefly to show how someone can know the purpose of the flowchart without guessing. Now, when you look at that flowchart and, when you look at the flowchart and you look at the at our formula that we do have, that we have been able to put, then you need to, what we have, we had something like this. So we had xn plus 1 is equal to 3 out of 4 into xn plus n out of 3 x cubed n, something like this. Now, at this point, in case you want to obtain, you can drop out the n's, these n's, and write this as x is equal to 3 out of 4 into x plus n out of 3x cubed. Now, at this point, when you open up your brackets, you'll end up with 3. When you open, you'll have 3. This is going to be x out of 4 plus 3 out of 4 n out of 3x cubed is equal to this x. So at this point, you can note that this 3 and this 3 can reduce, meaning that you can get x is equal to 3x out of 4 plus n out of 4x cubed. Now, at this point, you can note that 4 is a common factor, meaning that if I multiply through by 4, I can get 4x is equal to 3x plus n out of x cubed. So at this point, I can transfer the 3x this side, so I end up with 4x minus 3x is equal to n out of x cubed. So 4x minus x is the same as x is equal to n out of x cubed. So when you cross multiply, you end up with x power 4 is equal to n, meaning that your x is the same as the 4th root of n. So that means that the purpose is to compute the 4th root of a number n. So it doesn't matter how it is at times. So as long as you look at that formula that has been given to you, because then next time you'll find something like this. They'll maybe give you xn plus 1 is equal to maybe xn minus 1 plus n out of the maybe exponential xn. Still, you apply the same. Let me say this is xn. Let me make it better. Let me write it better. Let me say this is xn minus 1, something like that. And maybe they want you to find out the purpose for the flowchart. Still, you apply the same. You say this is the x into x minus 1 plus n out of ex. Now, the next thing you're going to do is that you're going to collect like terms. So what will happen that x will come this side. So you have x minus x is equal to negative 1 plus n out of ex. X minus x will give you 0 is equal to negative 1 plus n out of ex. So when negative 1 comes this side, you'll end up with 1 is equal to n out of ex. So when you cross multiply, you'll end up with ex is equal to n. Now, in order for you to be able to find out the purpose, it means you make your x the subject of the formula. So how should we make it the subject? By taking the natural log on both sides. So meaning I'll set the natural log this side the natural log this side. So this becomes x ln of E is equal to ln of N. So natural log of E is the same as 1. It's like having log of EE, which will give us a 1. So meaning that now we shall have here x is equal to natural log of N. Now for such, you'll say that the purpose is to compute the natural log of a number N. So that's how you can find out the purpose whenever you have been given the formula. But what I was saying also, maybe I can write it for the rest to be able to get it clearly, that when you are making your decision box, make it big enough such that you write everything on one, along one line, such that you do not break your inequality, such that everything like this can be able to fit along one line. Okay, that's what I wanted to emphasize. But please also, when you are drawing your flowcharts, do not forget the arrows, because those arrows are very important when demonstrating or showing the direction. So do not forget those arrows, because they are going to be very, very important to you. Yes. Okay. Allow me to stop the sharing. Okay, teacher carried.
Excuse me, Mr. Kaziba.
Yes.
There is a concern here. There is a concern.
Yes.
There is a question in 2022, number 14. The students are finding hardships with rearranging.
Okay, I think I'm going to allow me to first look for it. If you have the question, you could share the question in the chat. Then as we go on, we shall bring it back online. But I think
Yes,
I need
Mr.
to...
Kaziba.
Yes.
I wanted to comment about the presentation on that flow chart, especially the dry run.
Okay.
And the purpose of the flow chart. In the presentation, I've observed that the presenter said to get the fourth root of a number. But then when you look at the read box, we have a tolerance there, which is telling us when to stop, at how many decimals. So I think it would be better if a learner also tells us that the flow chart is to get the fourth root of that number, correct to 3 decimal places based on the tolerance value given. May even tell us that we are using an iterative formula. I think that would be much better to bring out all the essence of the flow chart.
Thank you so much, teacher Carried. Okay. Yes, Mwalim Fred, are you on? Let me see. Okay, I think he's off. Okay. Okay, thank you. Thank you, teacher Carried, for the submission. Please, students, take note when you are making the conclusion. Okay, I'm going to look out for that flow chart. I'm looking out for the paper, and then we shall look at it. But please be very careful when you are answering those flow charts, and then such that you can be able to pass it highly. Okay, thank you so much once again, Archbishop. I'm going to get that question. When I get it, I'm going to be able to display it again. Let me ask then another school that wants to present. I don't know whether Kangulumira, you are ready, but we had also, I want to find out whether Teacher Samuel, whether you are set now. Teacher Samuel, are you set?
Mr. Kaziba, I am sharing. Mr. Kaziba.
Yes.
I am sharing the question in the chat.
Okay, okay. Okay. Teacher Samuel. Popo, are we set? Teacher Pio, okay. Yes? Okay, we are not getting you clearly, but in case there is another school that is ready, kindly let us know as we wait for teacher Pio. Teacher Pio, are you set? Okay, Archbishop, we can continue. Let us go to number 108. Archbishop, go on for 108.
Similarly, we are requesting to share our screen.
It is very fine. Kindly. Yes?
Can you hear me now?
Yes, we can hear you.
But what I'm saying, you unmute Popol the 6 Anaka. You look from the list there.
Okay, I've seen it.
You unmute that one. It's the one we are using for presentation.
Okay.
Thank you. On to, come on, come over here. You are very good organized. Hello?
Okay. Okay, Teacher Pio, we are going to
Yes,
get
please.
back to you. Let
Can you
us
hear me
first.
now?
Yes, we can hear you.
Hello?
We can get you clearly.
Okay. Let me say this is Popol the 6 Anaka. Today we want also to present. We are going to use on-board presentation. We are presenting directly on the board. So I want to welcome the other schools who are on board so that they can view what we have today. Thank you. I will hand you over to the presenter.
Yes. Good afternoon, everyone. This is Orion Dennis from Popol, the S.6 Anaka. We're going to represent number 77, which is resolution of forces. We will have a force at this angle to the 60 degree, the vertical, and this one, the force of 7 Newton, and this one, 70 degree to the horizontal, force of 2 Newton, and this one, this is 80 degree to the vertical, force of 4 Newton, and then this one, 45 degree to the vertical, force of 5 Newton. So now the question is, find the magnitude and the direction of the resultant force. So now the simplest way of doing this, we're going to create a table where we have the forces, then we shall have the component in the x direction, then we have also the y component. I'm going to draw this table. The first thing we do is we first list all the forces. We start by this one. Here we have 7 Newton. We place this on. Then let the table back. Then we have this one. We have 2 Newton. Also this one we have 4 Newton. And then lastly we have 5 Newton. Then, for 7 Newton, when we are considering, when we want to find the resultant force, the direction is very important. So this one, when we resolve horizontally, you can see that the angle is increasing. When the angle increases, we are going to use sine. This is derived from the Pythagorean theory. But in the simplest way, when you resolve to horizontal and you see the angle, it depends on the angle given. When it is increasing, that complement will have a sign, but we can't see the direction. This one, when I resolve horizontally, is in the positive direction. So we have positive 7 sine 60. What about the y component? We will take the opposite now. When I resolve the angle reduces, I will have in the positive direction of y. That is 7 cos of 60. I come to 2 Newton force. It's the same thing I do. This time the angle is inclined to the horizontal. So when I resolve horizontally, the angle is reducing. So it will be, this time is cos, now this time 2, there is 2 cos, angle is 70, yeah, cos 70, I think it is degree, these are degrees. Then now we look at the y, then we look at the y component. When we resolve this force to the y, it is in the negative direction. So we're going to take the negative of it. But this time the angle is increasing, so we're going to consider the sign, but in negative direction. So we have negative 2 sine 70 is degree. Then we go to the 4 Newton force. The x component is in the negative direction. When we resolve horizontal, the angle increases. That means it's sine. So it is negative 4 sine 80 degrees. And the corresponding y component is also in negative direction. So we take negative 4, and then say the angle increases, this cos 8. And lastly, 5 Newton force. When I take the x component, it will result in a negative direction. The angle increases, that is automatically negative 5 sine 45. Then when I look at the y component, when I resolve, the angle decreases but in a positive direction. So we shall consider now positive direction. That is 5 cos of 45. Now what I do from here, I get the total now. The total of the x component also the one of y component. So from what we calculated, if you can also do from there, then I think you will get this very, the one of x component we got negative 0.729. That is the x component. Then for the y component, we had 4.51 Newton. See, this force is like Newton. Also this one. Now, since we know the total of x component and the result of the y component, the formula for getting the resultant force, the formula of getting any resultant force is equal to root of x squared plus y squared, where the x is the total of the x component and also the corresponding y, the total of the y component. So now my resultant force will be root of. So here we're going to take the whole of this even the negative. So even if it is negative, when we square it becomes positive. But it's better if I write it so that we show you have squared is negative now. So the x component is negative 0.729 square, then plus the corresponding y component is 4.521 square. And our resultant force is, after that we computed, we got 4.5221, is it? I mean, this one was, this y component, sorry, the y component was 4.4462, sorry. Then now this one is now the resultant Newton. So this is our resultant force. So now looking at the magnitude, so looking at the angle of this inclination from that angle, the direction of resultant force is given by theta is equal to tan inverse of y over x. The same, where y is the y component of the force and x is the total x component of the force, where we shall have theta is equal to tan inverse of y is this one is 4.462 out of 0.729. But remember there is a negative here, so after that we can get from our going to be 80.22. But the most important thing we have to know from here, the best thing is to first get, because we don't know where this is falling. So since you can also draw and from okay, initially I had this one because when I'm sketching I will have this 4 is imposing will be somewhere that is the x component and this is y. So that is 4. Then now the y negative 0.729. So you find that this 80 degrees is in negative direction. So because we know because of this negative, this 80 we are going to conclude. As you can also see from here. But if you were not to draw, you might think it is here. But since we have now sketched, this now becomes the inclination in the direction. So now, as we have seen from there, we did not correct this one very well. Sorry for that. This was supposed to be 4.662. There was some error, but I think it's okay now. So I think we can stop there for this number. Yes, there. Thank you so much.
Okay, thank you so much. There is a question. Samsung unmute.
to our president. Like for example, were you getting that angle? I thought after getting that angle, you have to state like the resultant of the force is this and this, then it acts to the what, to the horizontal. Then another thing about resolving the forces, say for example, like me who doesn't know the method you're applying, but if I resolve it to the horizontal, I first get the angle that is nearer to the what, to the horizontal before resolving. Then back again on you getting that angle, I thought you're supposed to sketch it very well, then you put the dotting down here, you first remove it from the Cartesian what? The Cartesian plane, like here. Maybe you can clarify more about that. Thank you.
Thank you for your issue. Your problem was about starting from here. For a slow learn, it will be very hard to know the method I've used. But now with time, when you're busy now, you have done a lot of practice. The simplest way, if you are resolving, you can see when I pull this thing here, will it increase this angle? If it increases, then you're going to apply the sign. And when it decreases, but your constant is also okay. When you find the difficulties, you can first get this angle to the horizontal. Then it will be now uniform. Then you know that when the result is horizontal, you automatically get a cos. But when now you're very okay with the method I've used, I think it is okay. The constant you have brought is true. For your case, you can first get this one, then now you resolve. For all of them, like for this case already, but for this one, the balance is 10. So we're going to use 10 and resolve the way you say. I think that part is okay. Then the one you have saved is also after now result and we have got the angle. It is reactive. We can now conclude the way you said. So you can say the resultant force is 4.521 Newton at 80.2 degree to the horizontal. So you can conclude like this now after getting the angle of inclination. So I don't think it may be there's anything you haven't understood apart from this one. Those are the
Okay, thank you. Yetula SS, is it a question? Okay, now when you look at your resultant, you can note that your resultant was below the positive horizontal. So when you are indicating there where you have said that the resultant is 4.521 at 80.22 below the positive horizontal.
Yeah.
Yes. So since it was below the positive horizontal, you can say below the positive horizontal. In case it is above, then you say it is above the positive horizontal. Now, when you say below the horizontal, it can either be positive horizontal or negative horizontal. So now you need to be specific that it was below the positive horizontal, since it was this side of the positive x-axis. But it was a good presentation. Yes, Samsung. Okay. Okay, so that is very good. Now, when it comes to such numbers, dear students, make sure you resolve very well. And before you make your final, before you make the conclusion, make sure that you come on writing your answers to 4 decimal places. The reason for writing to 4 decimal places is to keep within the accuracy levels. So whenever you round off what we call a premature approximation and you approximate to a few decimal places, it means that at times your answer may be a bit far away from the final answer. So always make sure you write at least 4 decimal places and carry the decimal places, the 4 decimal places, up to when you reach the final answer. Unless when what you have resolved is the terminating decimal. But in case it is a recurring decimal, please continue carrying those different decimal places, the 4 decimal places, up to when you reach the final answer. And always do not forget to conclude, and don't forget to get the magnitude. And always get your magnitude and get your angle, because force is the vector quantity, meaning that it must have the magnitude and it must have the direction. And the reason is those two things are really very important when you are describing what you call a vector quantity. Okay, thank you so much.
Thank you. I think we had also some good comments and concerns from other schools. And we still have another number to present. I don't know if you can still permit us.
Okay, which number are we presenting?
Number 90.
Number 90. Okay, we can present it.
Okay, thank you so much. Now we welcome another presenter to take over the floor.
Mr. Kaziba, can you hear me?
Yes, Mr. Ronald.
I just wanted to greet the team because I'm going off shortly.
Oh, okay, okay.
Dear teachers and students, I'm happy that we are continuing this afternoon. We had a good day yesterday, but I'm also happy that we are joining in this afternoon. The reason for a Sunday was to see if there are any friends of ours who cannot join us on a Saturday, and we don't have to leave them out. So I'm happy that you've been able to come back. Those who were not here yesterday, we are happy to see you and hope we are going to have very fruitful deliberations. I want to thank the teachers who are giving us a lot of time to this. I just want to mention one thing that I mentioned yesterday, and that is to encourage some of you to consider joining the teaching profession. I can see the presentations are superb. The capacity of being great teachers is very clear. Many of us discussed for our schools when we were at your level, and that actually made us the good teachers we have been. So I'd like to encourage many of you to think about joining us as professionals. But also, as you may know, the president is very clear. He would like to see that the teachers are paid well. And already the science teachers are being paid the best salary within the public service, but also the art teachers are going to be considered soon. So as mathematicians, we would like to encourage you to join the science teaching profession. The pay will be good, but beyond the pay, what we want is to have very committed teachers who are going to close the learning gap within this country. And I want to thank your teachers for the work they are doing because they are struggling to close the learning gap. I also would like to invite your schools to join in next week, starting next week. I know Mr. Kaziva is going to give the program, but we shall be having those evening sessions where we invite you to join in so that we continue learning together. And what is very important to us is to see you excel at your mock exam and finally at the UNEB exam. And we shall be ready to celebrate with you at the end of it all. So I thank you for joining, and I may not be here all the time, but I will be waiting to listen in to the recordings and see the presentations you made. Thank you, Mr. Kaziva and your team, and wish you the best this afternoon. Thank you.
Thank you so much, Mr. Ronald, for those remarks. Thank you so much for everything you are doing to ensure that children continue to learn. So next, we shall have Popo. Okay, let me spotlight them. Okay.
Good afternoon, everyone. I'm called Precious again from Popo the 6th. I'm going to present number 90, where the question was, given the numbers x equals to 4, y equals to 6, and z equals to 8, all measured to the nearest integers, find the minimum and maximum values. So they have told us to find the minimum and maximum values, but the A part was given us z minus x over y. So we shall start by getting the maximum values of all these, of x, y, and z. But how to get it, we shall add or subtract the errors. But error in each value in any number is got from a half exponent n, where n is the number of decimal places. So we shall start by getting the error in x, which if you're to multiply, x is to 0 decimal place. So if you're to use this formula to get the error in x, you're going to get that it is negative or positive 0.5. Then also the error in y, you use the same value, the same formula, which is negative or plus 0.5. And then that of z is negative or positive 0.5. So now we shall start by getting the maximum value of x and then the minimum value of x. Where for the maximum value of x, we shall add 0.5 to its original number, where if you add, it's going to be 4.5. And then we shall
Excuse me. Kindly
Yes.
put a negative. There is a negative you are forgetting on the maximum possible error. A half times 10 power negative n.
Sorry. Okay. So we shall now continue and get the minimum value of x, where we shall get our 4 minus 0.5, where we shall get 3.5. Then we shall also get the maximum value of y, where we shall add 0.5 to the original value, and then we shall get 6.5. Then we shall get the y mean, where we shall get 5.5 by subtracting 0.5. And also we shall get the z max, where we shall add 0.5 to the original, which is 8.5. Then the z mean shall subtract, of which to be 7.5. Then now we shall go back to our equation. We shall start by getting the maximum value of z minus x over y, of which it is max. But from this, we shall have our z max minus x mean over y mean. This is when you are going to get the x, this whole thing which is max, of which if you get your max minus the mean, here you're going to get a maximum value, and then if you divide by the mean, you'll also still get a maximum value. Then you shall come and then input our values that we have got, where our z max was 8.5. Then we subtract minus the x mean, which got us 3.5. Then we divide by the y mean, which is 5.5. Then our answer there, if you to work it out, here you get 5, divide by 5.5. So our max value here is going to be 0.90909091. Then we shall come and get the mean value of that, which is shall get us our z mean minus x max. So that if you subtract here, you get a mean value. Then also you divide by y mean, so that you're able to get a mean value. Then you come and input the z mean, x mean. So our z mean, we got it as 7.5 minus our x max, which is 4.5. Then you divide by the y mean, which we got as 5.5. Then if you calculate this, you get 3 divided by 6.5, for which our mean value here is going to be 0.415384661. This is for the part A of this number. Is there any question before I run this?
There was a concern that
Yes.
in the max there.
Yes.
What if x is greater than z?
Sorry?
Then what happened? There was a concern that in trying to get the maximum, like maximum here. What if x is greater than z? Then what happened? That's the question.
I think we shall still use the same value, because if you're to subtract and then you divide it by this mean, I bet you will get a less value than that.
Maybe you see.
I'm seeing some hand from Angola.
Yes?
Yes, Angola.
I was asking that, yeah, they told us that these values were measured to their nearest integers. So do we give our final answer to one decimal place, or do we give it to all numbers or something like that?
The final answer, how do you express, since they give the things?
Are you answering Popo?
Sorry?
Have you had that question?
May he come again?
Angola, come again. Okay, let them put it in the chat. Okay, Angola, come again.
The question was in the expression written for the mean, we had some concerns on the value of y after expressing it to get the minimum of the final expression. She had it as divided by y mean, and it was supposed to be divided by y max. Then also, in addition to that, there was a question posed that if the value of x was greater than the value of y, then the expression would not work. Like the minimum would become the maximum, then the maximum becomes the minimum. But then in our school, we had it that if it's
Maybe speak.
I think
Okay. Unfortunately, we have lost, but they are coming back. They are coming back online. But before, yes, as they get back online, I wanted to first attempt the question that was asked by Chitovo. That was concerning, the question was concerning the flow chart that was set in I think it was 2022. Yes, Kangulumira, you are going to come back shortly. So that question, it was a flow chart that was drawn, and it was not a common flow chart. This is the question the teacher has sent me that I've received. Now, when you look at this flow chart that was set, this flow chart was saying that the taxation system in a company is such that the tax is such and such categories. Now, as a student, the first thing you need to know is, what have I been given? They have given you different conditions, and all the money that has been given, this money is in dollars. At the moment, you may approximate and say that if someone is earning, this was the amount people were earning, getting as salary. If someone is earning below $2,000, $2,000, roughly take it in our Ugandan money, take it like 7 million. Yes, it is approximately 7.2 million. If we consider that the dollar is at 3,600, it means that this person was earning something less than 7.2 million. Meaning that if someone is earning less than $2,000, this person is not taxed. So meaning that anyone earning below 7 million and below, this person will not be taxed. Meaning that for such, you just print and give the money. Take an example. If at all it was now someone earning 3 million, for that one will be tax-free. No taxes, so you earn that money. However, if someone is earning between 2,000 and 5,000, roughly when I've considered that my dollar is at 3,600, meaning that if someone is earning between 7 million, 200 and maybe $5,000, which is approximately 100, that is about 18 million. So if someone is earning between 7 million and 18 million, that person will be taxed. So whereby A is the amount that person earns. So you multiply 2 times that amount the person earns, then divide by 100. Take an example. In case that person is earning 18 million, you will say 2 times the 18 million in Ugandan shillings, divide by the 100. Then you get the tax that is levied on that given person. So I'm trying to put it in our Ugandan context. Then anyone earning beyond $5,000, that means that if someone is earning beyond 18 million, it means that this is the formula that would be used in order for us to be able to get how much tax this person would be paying. So that's what the question wanted. So they gave you different formulas, meaning you had to make a decision on what to start with and how to start with. So now they gave us the different flow parts. So the first one, you have to know that the first thing always we have to do is to start. So I'm going to start. So this is going to be my number 1. I'm going to start my flow chart. Then if I'm to tax, it means that I must know the number of people. And we know that if I'm to tax some, to get some tax, I need to know someone. I need to know people. Meaning that the next thing that will come in next is going to be the number. So when you look here, N represents the number of taxpayers, the number of people who are paying the tax. That is the N. So N stands for the number of taxpayers, and T stands for the tax that those people paid, and S stands for the amount earned, or the amount those people are earning. So the next part I'm going to do, I'm going to find out how many people I'm going to start with. So this is going to be my second part, that I'm going to find out that I'm going to start with the first person. Meaning that when I'm drawing, I'm going to first come and I say the first part is going to be the start. After starting, I'm going to go on and I say, now I have my first person. N is equal to 1. Now, after that, come back and ask yourself, after knowing that I'm going to have the first person, what am I going to read? Or what do I need to know? I need to know the amount this person earns. So the amount that person earns is the reading, because you cannot tax before you know how much that person earns. So next, I'm going to read how much this person earns. In case this person is earning 3 million, then you read the 3 million. So that is the reading, which is A. A is the amount that person earns. Now, after knowing the amount the person earns, you come back to the table where you are going to make the decisions that if this person is earning less than 2,000, that is tax-free. Then that was the first thing. Now check out inside here and check out and ask yourself, do we have any condition related to less than 2,000? Then when you check here, you can notice that we have this first decision box, which tells us that is A less than 2,000? Because now you have read your A. You have read how much this person earns. Then ask yourself, is it less than 2,000? Then I'm going to come and I have that decision, that this is my decision here. And we say A is less than 2,000. I'll say, is A less than $2,000? Now, in case it is yes, in case someone is earning less than $2,000, that is the approximate, I've told you in Ugandan shillings is less than 7 million, then it means that person is not taxed. So if it is true, it means that this person doesn't pay any tax. So that means that I'm going to come and I choose this box. So I'll come here and I draw the box. If it is true that the amount is less than 2,000, that person is tax-free. However, if it is no, that the person is, if it is no, that the person is earning more than 2,000, then it means that person is going to be taxed. So what was the next range? The next range was between 2,000 and 5,000. Then look at the decision boxes you have. I have, is A less than or equal to 5,000? Is A, then after looking at this decision box, you ask yourself, if no, it means that you go to the next level, which is this. So I'm going to come here and I have another decision box. I'm going to draw it because I want them to fill. Then I ask, is A less or equal to 5,000? Now, then I ask myself, if it is yes, what does it mean? If it is yes, because here they told you less than or equal, it means that this person must pay the tax. If it is no, then that means that that person will not pay the tax. So if it is yes, it means the person will pay the tax. And how much is this person going to pay? It means this person will pay, because the formula corresponding to that range is going to be 2A out of 100. Now, after getting that, and if it is no, it means that this person is earning more than 5,000. So meaning that if someone is earning more than 5,000, anything beyond 5,000, it means that you have to compute the tax. So now for this case, it means that our tax that we are going to compute for that particular thing, it means that now I'm going to come here and I compute that my tax is going to be 60 plus 5 out of 100 into A minus 5,000. Then I'll ask my, so if this amount is beyond 5,000, then I'll compute my tax. After computing my tax, I'll come, the next thing I'm going to do, the next step, I'm going to come here and I do the print. So what are we printing? We are printing how much tax is levied, because these formulas are the ones that show us how much tax they are going to tax that person. So that is your T. Then another one, how much money does the person earn, which is A. Now, after printing, it means that I'm going to ask myself, but how many people are paying? How many people are paying? So then I'm going to have here another decision box, that is the number of people equal to 200, meaning that if it is equal to 200, I will stop. If it is less than 200, it means that I must go on and I continue. So now for this one, after printing, I'm going to come here. I will print, because this formula is for printing. But also here, since this person pays no tax, also I have to come here and I do the printing. So here I'm going to put another decision box. It is a bit small, but you have to just understand. So I have another decision box here, and this decision box here is going to tell us, is N equal to 200? Have you reached 200 people that you are taxing? So that means that this is the decision box I am on. If it is yes, it means that I'm going to stop. That is if it is yes. Meaning that if it is no, it means that I'm going to go back and I increase on my number of n. So that means that the number of n must increase if you have not reached the 200. So meaning that here I'm going to come and I say that if it is not, then I'll have n plus 1. So I go back and I again, I have to print to the second person, third person, fourth person, and like that. So roughly, your flowchart is supposed to be of this nature. So that's what you are supposed to do for this flowchart. So you must have had some idea on how the logic flow of how we can do the taxing, because taxing depends on how much money someone is earning. And also it is taxed in given ranges. Now, for such a question, in case it is awarding or they are giving marks for such flowcharts, the first thing they are going to look out for, one, and please do not forget, whenever you are drawing the flowcharts, make sure that they fit on one page. It shouldn't be that you have drawn a half here and you transfer the half that side. It must always be on one page. So here, they could award you a B1 for the start statement. Here, they give you the start statement, and also they can give you the initial value of n. That is the first bonus mark. Then number 2, they can give you a B1 for the reading statement that you have read. The other one they can give you, it can be a B1 for the decision, that the decision that A is less than 200 and the action taken. So the action taken is that yes, and if it is yes, this person is going to be tax free. Another bonus mark they can give you, it can be for this decision here. That one can be another mark. Another mark they can give you, but also here they give you the mark and the action taken, not just drawing. So the action taken is yes, and therefore you compute the tax. Another one they can give you, it can be the B1 for printing. They can give you another mark here for printing. Then another one can be a B1 for this decision that your n is 200, therefore you must stop. They can also give you a B1 for the loop for increasing the n, that if the number of people that has not yet reached 200, you must go back and increase the number of n. So that one can be another one. Then the last one, it can be this one, that if the number is above 5,000, then it means that you can compute the taxes. So that one can be another bonus mark. So those are some. So this number alone, just arranging, it had 8 marks. So the B1s, the way you are seeing is how they allocated the marks for each particular number. So for each particular thing. So those were around 8 marks for you. Just arranging and drawing your flowchart, given that you have put the right arrows, you have put the things in the right, you have placed them in the right way, and also you have made the different decisions and you have computed the different formulas. So that's how you had to do it. And now for this particular one, always now they were asking for the purpose. In cases for the purpose, it means that now you state it that the purpose of this flowchart is to compute and print the tax paid for a maximum of 200 people and the corresponding amount of money and in dollars. That would be the best purpose. So you say the purpose of the flowchart is to compute and print the tax paid for the maximum of 200 people and the corresponding amount and in dollars. Not to just stop and say that the purpose of the flowchart is to compute and print the tax. You need to go deeper, like what teacher Khalid told us. You need to go deep and say, for how many people? For 200 people. And what it is for the corresponding amount of money that each of those people earns. So that was briefly about. Let me hope, Chitov, you are now cleared about that particular number. For performing the dry run, you can just continue and do the needful. But allow me to end there, and then we bring in Kangulomira SS. Yes. Okay, Kangulomira. Okay. Okay, I think Kangulomira is okay. We can go back to Paul. Okay. Kangulomira, you are ready? Kangulomira? Okay, Kangulumira. Okay, I'm seeing them. Let me, sorry. Kangulumira. Kangulumira, unmute. Kangulumira, unmute. Okay, we can start.
I'm going to present these numbers 76, or the position. I said that two particles of mass kilograms and kilograms are connected by a light inextensible string passing over a small fixed fluid. Find the acceleration of the particles. Before we go further, let's first have the sketch of the fluid system. Yeah. Remote the height. These are forces. And since they are forces, to be recorded in newtons. That's why I have these units here. We are going to have tension in the screen. The tension is done in the cell in all the screens. This is just a type of screen. Therefore, they are asked about the tension. We are going to apply this Newton's law of motion, F is equal to mk, on both particles. But we are already informed that there are two particles. One is 6 kilogram mass, and the other is 3 kilogram mass. Therefore, this 6 kilogram mass will be pulling this 3 kilogram mass. Therefore, this one will be moving upwards with acceleration of 10 meters per second squared, and this one will be pulled the other one. Therefore, they will be pulled downwards by the 10 meters per second squared. Our acceleration. Now, using this equation, we are going to consider the tension in the screen and the body that is pulling. Since this one is bigger and it's pulling this 3 kilogram mass, it's going to be greater than the tension in the screen. Therefore, this one will be 60 G minus T equal to 68 using the above equation. Now, when it comes to this particle for the 3 kilogram mass, the tension is bigger than the mass of the particle, pulling the particle. The tension minus the fluid G equal to fluid A. This is our second equation. We are going to add the two things and we eliminate T since it is just a single number. 60 G minus T plus T minus 3G is equal to 6A plus 3A. Therefore, these ones are going to be eliminated. This one is negative and this one is positive. 6 minus 3 is negative 3 equal to a 9A. But you want the acceleration, you want to divide both sides by a 9. The acceleration is therefore be given by 1 over 3G meters per second squared. But you can convert it if you wish, and if you don't wish, you can leave it there. And if you were to compute it, you try to find it in order to be safe with your answer. Now, our part of the question is about the tension in the screen. You can either substitute the value of A in one of the two equations. You can choose the substitute equation to C minus 3B equal to 3A. Then C minus 3B equal to 3. That means acceleration is 1 over 3B. The tension will equal to D plus 3D. The tension will equal to 4 newtons, since it is tension in the spring. Now, part C of the question is asking about the force on the pulley. The force on the pulley. This is our force. We shall have a reaction force on the pulley R. We have tension in the string, tension T1 and tension T2. Tension T1 and tension is the same. But the policy is made of two strings, it's just one string. But there is this tension here and tension here. So therefore, find the force of the string F will equal to R, and it will equal to tension G plus T. Our force is equal to 2T. But we already have T as T is equal to 4 newtons. Therefore, the force will equal to a 2 times 4 G. And the force will be equal to newtons. Our force is equal to 8 G newtons. That's all. Question. Is there any question? This one is part still of the question. And if you wish to ask any question, although you have not asked it, you can ask. If no question, that's all. Wish you the best.
Yeah. Okay. Thank you, Kangulumira. Any questions? Mwalimu Fred, any supplement? Okay. I think it is well. It is well. But when it comes to such diagrams, please do not forget the directions. Do not forget the directions of on the forces, how the forces move. And also do not forget to reason that the biggest force will always be heavier than the other. We made some modifications on that questions. And the modification could be the force was hanging freely, vertically freely. So that would be the modification. But I thank you so much. Okay, Kangulumira SS, people want to see the tension. Okay. Okay, okay, I wanted Kangulumira. Okay, Kangulumira, I'm looking for you to spotlight such that people can be able. Okay. So hope now you can be able to see the tension. Yes. Do not forget, another thing you should not forget is that for such numbers, please, that's how you do the calculations. The force on the pulley is the reaction force, and we expect you to calculate it the way they have done it there. So unless someone has a question, but still when you are drawing your diagram, Kangulumira, at least make sure you demonstrate that the 6 and the 3, Kangulumira, the 6 and the 3 cannot be at the same level. At least one is heavier than the other. So you cannot tell me that the 6 kilogram and the 3 kilogram are balancing. So you must demonstrate very well that at least one is heavier than the other. Okay, yes, Mwalimu Fred.
Yes, please, Mr. Kaziva.
Yes, make some submission.
Okay, thank you. So, beginning with the number on the police system, I would like to make these observations. Now, with that diagram as it is focused there, first of all, the student needs to understand what tension is. Tension is an internal force, normally exhibited when a spring, a cable, a rope is stretched. When it is stretched. So I would ask every learner
to get the clear meaning of tension very well by using, say, rubber band. If you have a rubber band, of course, that one is elastic, but can illustrate very well, where one can hold both ends and stretches it. Holds both ends and stretches it. You will discover that from either end, very good. I think you moved when you were set. You can now hold it horizontally. Horizontally. If you have a friend there, you can be two. Your friend holds one end and you also hold one end. So we want to understand what tension is practically. Just hold one end. So I would like to ask for the discussant, the one who was presenting, where do you feel the rubber band wants to go at your extreme end there? Are you getting me? Where do you feel the rubber band wants to go at your end, the presenter, the one who presented the question? Mr. Kaziba, is there microphone on?
Oh, let me, a minute. Kangul Mina, you can unmute.
Yes, please. Just hold on one end. That could be end A or end B. No, let your friend hold one end and you also hold one end. Just like that. So let me start with the one in yellow. Just hold one end for instructions. Yes, the girl. Where do you... No. Yes, for the girl, where do you feel the rubber band wants to go? At your end there? At the point of where you are touching, where does it want to go? Very good. You have illustrated towards the center. Then the boy, where does it want to go at your extreme end?
Left-hand side.
Where does it want to go? For the boy, where does it want to go? Are you getting me? No, for you, the girl. Now I'm asking the boy. For the boy, the end you are holding, where does it tend to go? Is it towards yourself or away from you? Away. To which direction? Illustrate like the way the girl illustrated. To which direction? Are you seeing that? Towards the center of the spring. So now we summarize and say that tension is an internal force in the spring that acts at extreme ends of attachment. Extreme ends of attachment towards the center. Towards the center. So those are very many words, but we want to summarize them mathematically. So when you are drawing a portion of a string in any diagram which is under and which is stretched, you must show the two directions. An arrow from one extreme end, another arrow from the other extreme end. So I want you to improve on your diagram. No? Now that is at the same point. We are saying from extreme ends. They are downwards. Then let's finish with the other portion first. No, you are going to another portion. Let's finish with this other portion. The portion on your... I don't know whether you are getting me. No, come back to your original diagram. Your original diagram. First listen, then you work. You write. We are saying from extreme ends, so like that. Then the other portion also on your right. Indicate it very well. That arrow is not in the middle. It should be at extreme end. There. Like that. So whenever you draw a diagram involving pulley systems, take note of that the tension acts away from extreme ends towards the center. Some local books, they try to put it at one point. That one is practically wrong. It should be extreme ends. And don't show it using only one arrow. It should be those two arrows for every portion. That is one thing I wanted to correct on that. Then now, you may put this down for the candidates who are listening. Put this down. It is a summary about police systems. I'm speaking this from the common mistakes normally encountered. So one is that tension acts from extreme end towards the center. That is one. Two, when you have one string, you'll have one tension. I will use that language. One string, one tension. Two strings, two tensions. Three strings will mean three tensions, unless mentioned otherwise. So we are saying if the system is connected by only one string means the same string has not been disconnected anywhere throughout. So one string, one tension. Two strings, two tensions. Three strings, three tensions, in that order. In most cases at your level, we go up to three there. So I want to give you reference where you will find that. For a single string, you have seen that example there. Then for two strings, any that will involve a table. Maybe you have a table, a board on a table, then you connect it to another. Actually, when you have two pulley systems, one fixed at one end, then another pulley fixed at the other end. But in between here, there is a body. So in such a case, you'll find you have two strings. Reference to that is a question of 2015. UNEB 2015, section B. You'll get to that. Then three strings, you take 2014. 2014, that is UNEB also section B. That question was on the pulley system and had three strings. Therefore, we needed to consider T1, T2, T3. Then the last observation, which students normally make a mistake, is deciding when we have uniform acceleration throughout or when does it vary. The moment we have only fixed pulleys, if we have only fixed pulleys, then the acceleration will be the same throughout. The moment we have only fixed pulleys, the acceleration will be the same throughout. Then if you have two springs, three springs, the acceleration will be the same. But the moment we have a movable pulley, yes, that is 2014. When you check very well, I want you to focus there, candidates. You see that we have, on my right, there's that lower spring carrying a mass of 12 kilograms. That one is one string. Then from there, you have another spring connected to it, passing over a fixed pulley there. That is another spring. Then on the left, the one of 8 kg. That is also, so those are three springs, which means three tensions. Then in the one of 2013, 2015, 2015 is not in that question bank, but it was also drawn. But if someone has it, you would quickly do as you have done. 2015, the diagram was drawn. So, yeah, allow me conclude. I was saying, when you have a movable pulley, automatically the acceleration will not be the same. And the acceleration will vary accordingly, as you were taught at various schools. There's when one side will have acceleration A, then the other one half. Or when this one is A, the other one doubles. There's that one also. Then there are situations where we have relative accelerations. If this is A and the other one is A1, then the other one is A2, then we come up with what we call relative acceleration. You have those, you take note, you check in your notes. Maybe another time we shall have illustrations where you may have a body is moving, a pulley. Miss, I don't know whether you could illustrate something which I'm talking about, where we have a fixed pulley.
Sound.
We have a fixed pulley, but that fixed pulley is carrying a mass on one end, then on the other end it is carrying another pulley. We have a fixed pulley with a spring passing over. On one end it is carrying a mass, then on the other end it is carrying a pulley, which would turn out to be a movable pulley. So in such a case, the accelerations will not be the same route because there's a movable pulley. Yeah, I think that is that. I have not been able to illustrate that, but you draw back to your books and your respective teachers just to emphasize that. Because students normally do not know when to have variable acceleration and when to have the same acceleration throughout. So I just wanted to air out that. Then lastly, on the other question of resolving forces, just as one candidate or student advised, it is not good to keep mixing up on one force. One side you are using cos, another time you are using sine. It is good to get used to use what we call a ground angle. The angle it makes with the horizontal. The angle it makes with the horizontal. It is easier that way, other than the angle it makes with the vertical. So whenever you have an angle made with the vertical, quickly use the complementary or supplementary concepts, get the angle it makes with the horizontal, so that you know that horizontally it is cos, vertically it is sine. Horizontally it is cos, vertically it is sine. It is always easier that way with many students, other than mixing up. One time horizontally you are using sine, another time cos, you may easily make mistakes. And also taking note of the direction when you are resolving. Taking note of the direction when you are resolving. And always be practical. You can even use a pen. Let it lie along the force you are resolving. Then be practical. Turn it through the angle you are resolving. Turn it through the angle you are resolving and see it to yourself that it is pointing either to the left or to the right, or downwards or upwards. So, yeah, that is good. So if we have any force there, maybe like 80 newtons, making an angle of 40 degrees with the vertical, and pointing away from the origin. So maybe 80 newtons, 80 newtons. Yeah, if you got your pen and with the lid on, you put it to lie along that 8 Newton force. So to resolve it horizontally, it is simply make it lie horizontal. So it means it will turn through a certain angle. That angle, we do not know it, but we can get it. If the other one is 40, definitely this will be 50. So if you lower your pen, so that would be the adjacent, just next to, which is now 8 cos of 40, cos of 50, pointing to the right-hand side. So other than using 40, from experience, I've seen that students who keep using the angle as it is, they keep messing up. Always look for the angle it makes with the ground, that is with the horizontal or x-axis, so that you know horizontal is cos, vertical it is sine. Then you only remain with the issue of deciding whether it will be to the right or to the left, or upward or vertically downward. So automatically, again, when we resolve vertically, it turns through 40 degrees, which would be 8 cos of 40. But we are saying let's use the same angle. So that one becomes 8 sine of 50. Always use the uniform angle, and once this is cos, the other one will be what? Sine. For those who find difficulties with it, resolving. Maybe Mr. Kaziba, we can have one in the third quadrant. In the third quadrant, pointing towards the origin, using the same diagram, pointing towards the origin. Maybe it is 10 newtons. 10 newtons, making an angle of 30 degrees with the horizontal. Yeah. Then now, students, you can be practical again. This is a topic that looks to be simple, but again, through experience, it is a challenge to many students. Moreover, it carries on to other topics. When you are dealing with moments, you find that it is all about resolving forces. Then we apply a little of moments. When we are dealing with relative motion, it involves resolving those velocities if given angles, bearings. So resolution of vectors, forces, is a very crucial aspect. So again, if you put your pen along that 10 Newton force and you resolve horizontally, which means make it horizontal, you turn through the nearest angle. You rotate through the nearest angle. So the question is, where will it point? Yes, you discover that it will point to the right-hand side. As much as it is on the left, it will point to the right-hand side, therefore it will be positive horizontally. So we shall have 10 cos of 30. 10 cos of 30. Then vertically, again, I wish that you put your pen there with the lead pointing up, showing the arrow direction or the direction of the force. Where does it point? You discover that it points upwards, vertically upwards. Therefore, as much as it is below, it will be a positive force. We are not concerned with the direction and magnitude, not the position. We are only concerned with the direction and magnitude, not the position. So eventually we shall have 10 cos 30 degrees, then 10 sine 30 degrees. I'm emphasizing uniform angle. Whenever you are resolving and you are using the ground angle, the vertical one is always sine, the horizontal one is always cos. Don't complicate things by mixing the angles. So if you wish, you can put these resolutions, like I saw the other candidate was putting them in a table, which was okay. But you can straight away put them in vector form. If we are resolving, we can put in vector form. Maybe we have x, y, x as the I component, in column form, perhaps x, x in column form, then y equal to. Then we resolve our 8, which will be 8 cos of 50, 8 cos of 50. Then automatically it will be 8 sine of 50, taking note of direction, plus. Now we go to 10 Newton force, which will be again 10 cos of 30, then 10 sine of 30. So let me conclude this by Mr. Kazibe again. You can, let's add there 1 in the second quadrant, 1 in the second quadrant, 1 in the second quadrant pointing away from the origin. Another force maybe of 60 newtons, making an angle of 60 degrees with the vertical, 60 degrees with the vertical. Yeah, we can now resolve it. So candidates, if you are following us, you can try. We are going to add that, but let's move together now. What will it be if we are adding it to we are resolving using vectors? So what will it be? Let's use now the ground angle, not that angle which it makes with the vertical. Always use the ground angle. So what will that be? Yes, it will be 30 degrees. So when we resolve, putting your pen there being practical, you see that when you make it horizontal, where will it point? Yeah, you discover that it points to the left-hand side, and therefore, will it be positive or negative? Yes, it will be negative. So we shall have -6 cos of 30. We can put it in column form to the other ones. Then we also resolve it vertically. We always turn through the nearest angle. So 6 newtons again, put your pen there along the 6 Newton force, resolve it vertically. Of course, some of you are very comfortable with this, but we are looking at a situation where everybody gets on board. So if you already know this, don't say we are wasting time. As teachers, our wish is that we have as many students passing mathematics, physics, chemistry, biology, general passing, so that many can be enrolled into those fields of sciences, because the world is transforming itself very fast along what we call STEM, science, technology, engineering, and mathematics. So we want almost everybody to get on board. So that is that. I just wanted to illustrate on that. Sometimes the question can instruct you to resolve forces in vector form. Like 2000, you check either 2002 or 2000. It was a hexagon, which they said by expressing each force in vector form, find the magnitude and the direction of the resultant force. By expressing each force in vector form, find the magnitude and direction of the resultant force. So you check around 2000 there or 2002 in those question banks, you will see such a question. Then lastly, I don't know whether it is in this, many questions in past papers are about a hexagon and a square. So sometimes when they set a rectangle, Mr. Kaziba, I think we are done with this.
Okay, thank you so much, Mwalimu Fred. Let me hope everyone has got now a hint. Those who have never done anything with mechanics, I feel now you are very comfortable. At least you have picked a leaf and at least you have something you can show. Okay.
Let me
Samsung,
just
is it a
add
question?
Let me just add one thing.
Okay.
So, Mr. Kazwastiri, you can illustrate this. When it comes to a square, which is very common, sometimes among the forces that have been maybe given along the sides of the square, once in a while, a force may be along the diagonal or along both the diagonals. Like last year, 2023, I think it involved a force along both the diagonals. Now, because it is a square, if they say square A, B, C, D, of course, we all know that a square has all sides equal, like that. Each angle is 90 degrees. And because of that geometry of a square, then the angle the diagonal makes with the horizontal is always 45 degrees. Because of the geometry of a square, the angle the diagonal makes with the horizontal is always 45 degrees. It is always 45 degrees. My emphasis here is it is not the case with the rectangle. Students, it is not the case with the rectangle. So if a question has been given for the rectangle and it involves a diagonal, maybe a diagonal having some force there, so that angle is not 45 degrees. Don't rush to baptize it 45 degrees. Additional information will always be given to enable you find that angle using trigonometry. So take note of that and look out for more questions involving a rectangle. Involving a rectangle. The square is very common like that. So that is again what I wanted to emphasize. So in paper 2, always read the question with a high degree of patience, summarize your information. After summarizing it, look for concepts to be used or formulas to be used. Don't rush with it. When you rush, the force may be maybe along AC. They have said AC. Then for you, the following year, maybe they say CA. But because you have crammed that last year it was along AC, the arrow was pointing up. Then the following year, they say CA, which means the arrow will point the other opposite direction. But because you are rushing, you will see CA as in AC. So they need that degree of patience. Don't be too fast. Don't be too slow. What we need are correct answers. Those 3 hours, if well utilized, you can pass very well. Because my experience again is that very good students, good mathematicians end up getting B's, C's instead of S because of the supersonic speed they always write their things with. Before they write a correct thing, you'll find someone has even said 3 times 2 is 9. When you call him or her, you say, 3 times 2, how did it become 9? Cannot easily tell you. But it's as a result of writing very, very fast, rushing. So let us be moderate. Yeah, that is that, Mr. Kaziba. That's what I wanted to comment on the resolution
Okay.
of the
Okay, thank you so much. Let me hope at least we are there now. Okay. Okay. Now we are going to go on to the another number, St. Joseph's Hill SS. St. Joseph Hill, Chambogo. Kindly unmute and take us through.
Osima, you come.
Turn on your video, St. Joseph. And then you are going to disconnect one of the microphones. Okay, which one are you using, St. Joseph? Are you using Campus Media? Just disconnect one of the audios. Either disconnect the... Okay. St. Joseph, now show us the board. We are just seeing the students. Okay, I think St. Joseph is not yet set. Okay, let us first go back to St. Paul. Teacher Opio, we can finish that number. Anak, let's finish the number.
Hello, hello.
Yes, we can go on.
Now, you activated my personal account. You have activated the one for school. The name Popol the 6 SS Anna. Okay, thank you. Okay, thank you. We are now on. So we want to resume from where we ended.
So we are very sorry for the inconvenience which shall continue from part B of the question, where they have told us to get the maximum and minimum values like this. So we shall start by getting the maximum, where the maximum value shall use this, shall use the x max into the y max minus z min, so that you can be able to get the maximum value, then you divide it by the z min. Where if you compute it, we shall get our values from where we got at first this side, then we shall calculate. But then if we reach here, we shall get a negative value of which error is not negative. So we shall find the magnitude of the value we have got so that we can get a positive value. Then we shall come and get the minimum value of which we shall get our x min into y min minus z max. Then we shall divide it by the z max. Then if you compute, we shall still get the same value, which is a negative. But there is no negative error, so we get the magnitude. Then after we shall get a positive value. Then we had a question from one of the schools that, since in our question we have been given a whole number, how comes I'm writing all these? Remember here we are dealing with errors, so there is no way we can round off, because if we round off again, we shall be getting more errors. So we shall write the whole answer as we have got it. Then also another question came up from one of the students saying, in case we are getting the mean value, and then we happen to find that, sorry, I think it is the max, then you happen to find that this Z mean is bigger than this Y max. For us to get this max value, we shall just interchange the bigger value that is there, interchange to bring it this side, and then we shall make it the max, and then the Y we shall take that side, and then we shall calculate. So I think that is all, unless there's any question. So I guess if there is no question, I think this is where we shall end. Thank you for listening.
This us to use what? That is.
Someone is asking me to repeat again, so I'll go over it again. The question was telling us to find the maximum and the minimum possible values of this question that has been given. So we shall start by getting the maximum value, of which the maximum value for us to get it, we shall get our x max into y max minus z min over the z min in order for us to get a maximum value. But then if we compute, we shall get our answer as a negative value, of which error is non-negative. So for us to get a positive value, we shall get the magnitude of the answer we have got. Then after we shall end up with the positive value of the error. Then so shall be the same this side, of which I explained that here, after getting a negative value, shall get the magnitude. But then there's no way we can round off to anywhere now, because if we round off, we shall continue getting errors. Because error, you just write the whole answer as you've been given. So I think I'm done.
Hello, Stephen.
Yes. Okay.
Maybe if we have some concern from other schools, we can display them or we can receive.
Okay. Ngola, hi.
Good evening. Some concern is we are getting the range of values, not an error. So how comes again she's getting the magnitude of those values? Thank you.
Maybe they repeated it.
Please repeat your question.
Ngola, hi. Repeat your question.
Okay, the question is, we are getting range of values, not the error. Now, why is it that we are getting the magnitude of the range of values?
I say
Because that number expects us to get the maximum and minimum possible values of that expression. Now that expression lies in the negative part of numbers. Now if you say the maximum possible value of that expression is a positive, yet that expression always gives you negative answers, then how is that going to be the maximum and the minimum? And we're not looking for the error, we're looking for the range of values. How do you say that because errors are not negative, we get the positive? That is not the error, it is actually the maximum value.
No, the question is, we are not computing error. We are computing the maximum and minimum value. So why are you getting the maximum? We are not getting errors, we are getting values. That is the concern.
Sorry, I understand making mistake. So the values are negative, since we are not getting the errors. But if we are to be getting the errors, I think our answer will remain here. But if we are to be getting errors, that's when we will get the magnitude. So, conclude. So I think this is a conclusion we shall make it.
Yes, hello, Stephen. Hello?
Yes.
We are really grateful for giving us the platform. We hope to continue collaborating anytime we have such kind of presentations or seminar. But from me, I also have no more to say. I'm only grateful. Thank you.
Okay, thank you so much. Let me first, teacher Nabwe, do you have something to comment? Mwalimu Fred, anything to comment? Okay. Okay, Ngola, hi.
The thing is, again, you have interchanged the final answer. You have placed a maximum to be the minimum, then a minimum to be the maximum. If you compare negative 0.6 and negative 1.2352, which one is big, which one is small? Oh, sorry. Sorry.
Okay. So Ngola, I think, okay. Okay,
When
I
you look
think
at here, the first value we got was this. The first value they got was this, corresponding to the maximum, and the second value they got here corresponds to minimum. So in the final conclusion, this is exactly what the presenter also noted down. For minimum is this, and maximum is the other one there. So maybe you can check. Thank you.
okay, thank you so much. But also the students, when you look at those values, negative 0.6 and negative 1.2, actually you can note that negative 0.6 is bigger than negative 1.2. So kindly check note of that. Okay.
All right.
Next, we are going to go, there is Alinda Wilbur. Kindly, I don't know whether that is Wilbur. I don't know whether you're still on the call. I don't know which school was that wanted to present. Alinda Wilbur. Kindly, are you still on the call? Okay, we can first go to Kangulumira. Kangulumira. Kindly, Kangulumira public. Kindly unmute and you take us through the number.
We are doing number 94. Show that the iterative formula based on Newton-Raphson formula for finding the equation x equal to. So this is the same as x equal to n power 1 over 6. We are going to multiply this 6, this side and side. We get x power 6 equal to n. Then we subtract n this way. X power 6 minus n equal to 0. We let this to be our f of x. So we are going to differentiate. We get the derivative of this. F derivative of x is 6x power 5. Then when we differentiate a constant, we get 0. So xn plus 1 equal to xn minus f of x over f derivative of x. Therefore, xn minus f of x is this, x power 6 minus n over the derivative, which is 6x power 5. So we are going to, this is pure math, 6xn power 5. This is xn. When we multiply this one this way, and we make this negative to enter, we are going to get minus x power 6 plus n. We have multiplied 6 this way, sorry. This is 6xn power 6. So when we subtract, we are going to remain with 5xn power 6 plus n over 6xn power 5. But when we factorize out 5 over 6, we are going to remain with 5 over 6 into xn plus n over 5 xn power 5. This is xn plus 1. Yeah, I think we have reached on what we want. No, it's power 5. That is part A. Then part B is telling us to draw a flow chart that reads n and the initial approximation x naught. So to draw a flow chart, we start with the oval, that is start. We draw an arrow showing them where we are going. Then we show them that n equal to 0. That's what we are starting with when n is 0. Then we are going to read. We read, because they have told us that read n at the initial approximation x naught. We are going to read n and x naught. After there, we show them the formula. We use this formula that we derived in part A, that is xn plus 1 equal to 5 over 6 into xn plus n over 5 xn power 5. Yes. After there, we test we are asking, is xn plus 1 minus n under the magnitude less than or equal to the tolerance? If no, we are going to improve our n. That is to say, n equal to n plus 1. Then we improve the xn. That is to say, xn equal to xn plus 1. Then Then after there, we go back to the formula. If no, then if yes, we are going to print. Because in the question, they told us do a flow chart that computes and prints the root. We are going to print xn plus 1. Then after there, because the space is not enough, let us go this way, but it's showing that we are continuing down. Then we stop. I think the flow chart is done. For part C, they have told us taking n as 26, and x naught as 1.5. We perform a dry run for the flow chart. When they say to perform a dry run, this is what they mean. We are going to start with our n. When n is 0, then here we are going to have our xn, which is the one they have given us, the initial approximation. This is 1.5. Then we go to our xn plus 1. The one we will get after putting that xn in the formula and the other n in the formula. Then after we shall get the magnitude of xn plus 1 minus xn. If we reach a point when the magnitude of the difference of the xn plus 1 and xn is less than or equal to the 12, then that's where we shall end. So we are going to substitute this n and the x naught into the formula. Yes. For the first substitution, xn plus 1, we are going to get 1.8206. Then their magnitude is 0.3206. But because the magnitude is not less than or equal to the tolerance, because our tolerance, they told us to use, when I talk about the tolerance, I mean like here they have told us, computes and prints the roots to 3 decimal places. To get the total, we depend on the number of the decimal places they have told us in the question. For example, here they have told us 3 decimal places. They are meaning 0.0005. If they tell us 2, that is 0.005. If they tell us 1, that is 0.05. But they have told us 3. So this is the tolerance that we are going to consider. Since the magnitude is not less than or equal to the total, we are going to continue. As the flowchart shows us that if no, we are going to improve the n. That is to say n plus 1. So this is 0. When we add 1, we are going to get 1. And also we improve the root. That is to say xn. We say xn plus 1. But this xn plus 1 we are going to put here is this one. We are not going to say that this xn plus 1, but we use this one. So this what we are going to put here. So when we substitute this xn in the formula, we are going to get xn plus 1 as 1. Zero 8 6 8. but still their magnitude is not less than or equal to the 12. We are going to continue, we are going to improve the n. That is to say this 1 plus 1, that is 2. For xn, I told you that since they have told us that we xn plus 1. So here we're going to put this one here. That is 1.7338. So when we put this xn in the formula and our n, we are going to get 1.7214. When we subtract this from this one and we get the magnitude, we are going to get 0.0124. But still the magnitude is not less than or equal to the 12. So we are going to improve our n. This is n plus 1, that is 2 plus 1, we get 3. Then xn, we put xn plus 1, that is 1.7214. When we put it in our formula and our n, the value of xn plus 1 is 1.7212. So we subtract this from this and we get their magnitude. Their magnitude is going to give us 0.0002. So for this case, the magnitude is less than the 12. Therefore, we stop there. So if they ask you the root, we take this one as the root. But they have not asked us the root, they have just told us to perform a dry run. So I think we end there. Thank you. Any questions?
Thank you so much. I'm looking through the chat. Someone just wanted to help them to manage the second last step to show them how. Yes, the second last step, how you reach to 5 out of 6 xn. The other side, for part A, how you reach to the conclusion. Someone wants some clarification. Yes, how you reached there.
So at this step, okay. This is the same as 5xn power 6 over 6xn power 5 plus n over 6xn power 5. So this one is going to produce this one. This is the same as 5 over 6xn plus n over 6xn power 5. But according to what they have given us, we see that 5 over 6 is factorized out. So we are going to factorize out 5 over 6. We get xn plus n over 5xn power 5. So when we make this to enter, I'm just showing you so that you understand. We are going to get 5 over 6xn plus 5 over 6 times n over 5xn power 5. This one is going to cancel with this. So we remain with 5 over 6xn plus n over 6xn power 5. I think you can understand this step from here. That's it. Any other question?
Thank you. Yes, Archbishop Chwanuka.
Yes, I want to ask you that why is it that for the initial approximation you have written it to one decimal place? And another question is that why have you used the way they said you have not told us use it. Why haven't you reached the point where you're having the difference, which is 0 is 0?
The question is not so clear. Ask again.
Just think, why is it that in the dry run, your initial approximation is to 1 decimal place, 4 decimal place? Yes?
Okay.
Why is it that you have used the tolerance, yet it was not given to us?
Getting the
Having 0, 0 as your difference.
Like they're asking that the tolerance was not given. So why have you approximated to that particular one?
The tolerance was not given.
The tolerance is given. I've told them if that we get the tolerance from the number of DPs they have given you in the question. And I remember, like when I was here, I told them if they had told us that computes and prints the roots to 3 DPs, the formula of the tolerance is a half exponent n negative n. This is a half exponent. The negative n is the number of DPs that they have given you. That is to say exponent negative 3. This one gives us 0.0005. I don't think that it's very rare to tell you that using the tolerance this, but according to the questions I've done, they are used of giving us the number of DPs. So we use this formula and we get the tolerance. Yeah. Okay. You want the number of DPs here to be the same as those ones here. I think this is the same as this, but for your own information, you can add those zeros.
Okay, thank you so much. Please, whenever you are computing or you are making your dry run, make sure that the number of decimal places, they are more than to the number of the decimal places to which you are going to write your answer to. In case the question wants you to write your answer to 3 decimal places, it means that in order for you to avoid premature approximations, increase the number of decimal places you are carrying. The way you have seen her carry 4 decimal places on each computation. So do not write to 2, do not write to 3. Don't write exactly to 3. Make sure they are more than the conclusion that you are going to be coming up with. Otherwise, the question is well answered unless someone has a question. But the question, that was really very good. Thank you so much, Kangulmira Public School, for that presentation. Okay. Next, we are going to thank you, Kangulmira. Okay, Archbishop Chiwanuka.
We are ready with number 108.
Okay, come in, then after we shall have St. Joseph.
Can we share our screen?
It's kind of go on.
Right.
Good evening to you all. My name is Lamboza Abbott and I'm taking you through number one. A bit of B is the third. Question 1 is that find the probability that neither A nor B occurs. as we can see, these ones were given from the question, probability of A, probability of B, and probability of A given B. Now, I'm going to use the contingency table. First write A and A complement, B and B complement, here A intersection B, A complement intersection B, A intersection B complement, and A complement intersection B complement. When we add this, A plus A complement, you get a 1. Then B plus B is equal to 1, intersection B plus A intersection X, and probability of
Oh, unfortunately, their network is really disappointing, but let's give them some time to get back. But before they get back, Itula SS wanted to make some submission. Itula SS, kindly go on. Itula, unmute.
Yes, hello, are you getting us?
Yes, you are clear.
We would like to briefly elaborate something on question 90B. So you're most welcome.
Yes, thank you so much. My name is Benson Nodo Alex, a student of Itula Senior Secondary.
Excuse me. Mr. You
Sorry?
Go on, Itula. Bishop Shonka, a minute.
Yes. Yeah, in question 90B, we had to, when we shall be getting the maximum, because if we are to see these values Y and Z, we realize that Z is higher than Y. Z is higher than Y. So for us to get the maximum value here, we first remove the negative. We first pull out the negative so that we shall have negative X in bracket Z minus Y. So in that case, since we have negative, if we are getting the maximum value, we shall be minimizing because a small negative is the higher value compared to a higher negative. Therefore, when we shall be getting the maximum, we shall be aiming at looking at the minimum value since we have a negative. Thank you. That is my submission.
Okay, thank you so much. That one is also very fine. It is very fine. Okay,
All right,
thank you,
so much.
Itula SS. Okay, Archbishop, come in. Archbishop, your network is not yet fine. Your network is not yet okay. Okay. Archbishop, let's allow you to have.
Can you hear us?
Yes.
Are we there?
Okay, a bit better now.
Can you?
No, it's not yet fine. Let us first try St. Joseph, and then we come back to you. Okay, St. Joseph. St. Joseph. St. Joseph. Oh no. St. Joseph, turn on the other video. Okay, I think that is not the St. Joseph. I saw St. Joseph, St. Joseph. Okay, this one. Okay, I think, okay. St. Joseph, okay. Kindly unmute. Unmute.
I have unmuted. Okay.
Okay, let us start.
Okay. My name is Katsime Rachel, a student of St. Joseph C Secondary School. I'm going to present number 74. It's saying an object of mass 4 kilograms is initially at rest at a point whose position vector is -4i plus 2j. If it's acted upon by a force F is equal to 14i plus 21j plus 24k. Then they want us to find the acceleration. From the formula, F is equal to mn. But we have our force, so we have the mass, which is equal to 3, which is equal to 4 kg. So it will be 14, 21, and 24, which is equal to 4. So now, to find the acceleration, we are going to divide through by 4. So our acceleration is equal to 14 over 4 I plus 21 over 4 j plus 24 out of 4 k meters per second squared. So this is our acceleration. So part B is asking us to find its velocity and speed after 2 seconds. Find for velocity, V, we get it from integrating acceleration. So our V will be equal to the integral of 14 over 4 I plus 21 over 4 j plus 24 over 4 k dt. So now here, when we want to integrate, this will be equal to 14 over 4 t, then I, plus 21 over 4 t, then under j, plus 24 over 4 t under k, plus c. So since they said that the object was initially at rest, so we need to find from its velocity. So from v at time t is equal to 0. So velocity is equal to 0. So we're going to substitute in for v. So this one, if it is 0, is equal to 14 over 4 times 0 under I plus 21 over 4 times 0 over j plus 24 times 0 over 4 under k plus c. Since this is all equal to 0, so our c, so c is equal to 0, 0, 0. So we substitute in the value of C back here. So our V is equal to 14 over 4 T under I plus 21 over 4 T under J plus 24 over 4 T under K plus 0. So now our V is equal to 14 over 4 T plus 21 over 4 T plus 24 over 4 T under K meters per second. So this is the velocity at T is equal to 0. So now they want the velocity and the speed after 2 seconds. So V at 2 seconds is after. So it will be at T is equal to 2 seconds. So V is equal to, so we are going to substitute in the value of T, which is equal to 14 over 4 times 2. This is R plus 21 out of 4 times 2, then under J plus 24 over 4 times 2 under K. So here now we can put in the values. We can substitute in. Where we get V is equal to 7 R plus 21 over 2 J plus 12 K meters per second. This is the velocity after 2 seconds. So part C is saying we find its distance from origin after 4 seconds. So to get distance S, we are going to integrate V dt. So now we are going to integrate the V, so which is equal to the integral of 14 over 4 T under I plus 21 over 4 under, this is I, this is J plus 24 over 4 T under K dt. So now here we are going to integrate, which is equal to 14 T squared out of 8 under I plus 21 out of 8 T squared under J plus 24 over 8 T squared under K plus C. So now this is the speed S, but we want to find for the value of this C. So to get the C, remember in our question, we had the initial, the position vector, which is equal to position vector of S, which is equal to -4I plus 2j. So at t is equal to 0. So we are going to substitute it at t is equal to 0 in our equation to get for the value of c. So at t is equal to 0, s is equal to -4, 2, and 0, which is equal to 14/8 times 0 squared under I plus 21/8 times 0 squared under j plus 24/8 times 0 under k, then plus our c. Since all these are equal to 0, so 4, 2, 0 is equal to c. So this is our value of c. We are going to substitute in the value of c in our equation. So s is equal to 14/8 t squared under I plus 21/8 t squared under j plus 24/8 t squared under k plus -4i plus 2j. So now we are going to collect the like terms. We get this one, we add it on this on the I, and we get the 2j, we add it on the j. So which is equal to 14/8 t squared minus 4i minus 4, but under I plus 21/8 t squared plus 2, then under j, then plus 24/8 t squared under k. So now here you can substitute in. So they need us to find the distance at time. At time is equal to 4 seconds. So s is equal to, which is equal now to 14/8 times 4 squared minus 4 under I plus 21/8 times 4 squared plus 2 under k, then plus 24/8 times 4 squared. Which is equal to 24i plus 44j plus 48k meters. So this is the distance after 2 seconds. Thank you. Any questions?
Okay, thank you very much. Now, can we complete the question? Depending on the question wanted us to find the distance, and what you have is displacement. Yes, so that is the displacement. So the question wanted you to find a distance. So in order for you to obtain the distance, go on and get the magnitude. So that is displacement. So continue.
So we get the magnitude of S, which is equal to 24 squared plus 44 squared plus 48 squared, but under a root. So when we are looking for the distance, so we need to get the displacement. After getting its displacement, so we get the magnitude of the particle. So when we are getting the magnitude, this is 24 squared plus 44 squared, which is under the J, and we get the 48 squared under the K direction. So, which is equal to we get now the 34 squared. Squared is equal to 576 plus 19,736. Then plus 2,304. So the distance is equal to 69.33. This is 69.397 meters, which is our distance.
Okay, thank you. That is very good. That is very good. Okay, now I'm going to start from that point, and you are going to allow me now to share. I want to thank you so much for doing that number. It was really a good presentation. Thank you so much, St. Joseph's Hill SS Chembogo from Fort Potro. It is a nice presentation. Allow me now to share my screen such that I can summarize that topic. I'm going to summarize that topic such that those people who don't have an idea can as well be able to pick an idea. Now, for this particular number, we have done, has been now very common. Those people who have been looking through the past papers and the rest, you have seen that vector calculus is very common, meaning that for anything you are doing, you must be well prepared for it, that in case it appears, then you must be very sure on how to attempt it. But what is very important, there are 3 things that they usually ask. One of it is going to be what we call displacement. And when we talk about displacement, displacement is the change in the distance, is the change in the distance in that particular direction. We are talking about the distance you move in a particular direction. That's what you call displacement. Next is what you call velocity. Now I'm summarizing. Velocity means that change in the displacement, the change, the rate at which the distance you move in a particular direction changes. And then lastly is going to be what you call acceleration. These are the common things they are going to be asking. And acceleration means the rate at which velocity changes. Now, these 3 things go hand in hand. Displacement will connect you to velocity. Velocity will connect you to acceleration. That is one. Now, what do you need to know is that when I'm moving from displacement going to velocity, moving from velocity going to acceleration, what do? Always here we differentiate. Here we shall always differentiate. So in order for you to be able to obtain velocity, you differentiate displacement. In order for you to be able to obtain acceleration, you differentiate what we have for velocity. What do you need to know is that when I have acceleration, I can be able to obtain velocity. When I have velocity, I can be able to obtain displacement. And what do? Whenever I'm going back in the reverse order, here it means I'm going to be integrating. So this is going to be integrating, and this is going to be what you call integrating. So please take note of that. And always this one is going to be with respect to time. With respect to time. Now this is the summary for that whole topic. And how do we represent displacement? Displacement, we have 2 letters. We can use S or R. Velocity, we use always V, and acceleration, we can use our A. So what does it mean? It means that when I have displacement, I can be able to obtain velocity. When I have velocity, I can be able to obtain what we call acceleration. So now I want to move from one way to another. Now, in case I start from acceleration, we know that acceleration is the rate at which the velocity changes with time. So in other words, in order for me to write it, I will say it's the change in velocity out of the change in time. This is what we call acceleration. So acceleration means the wave velocity changes with time. So, now, once you reach this point here, what are you going to do? In order for you to obtain velocity, it means that I can do the cross multiplying. When you do the cross multiplying, it means you have A dt is equal to dv, or what you can write as dv is equal to A dt, meaning that in order for you to obtain velocity, I'm going to come integrate. So meaning our v will equal to the integral of A dt. Then plus your constant. Now, I want you to be very careful. So now, when you have velocity, then this is what you are going to obtain. I'm ignoring the constant of integration. In case you have velocity and you want to get displacement, you know that velocity is the rate at which the displacement changes with time. So in order for you to get displacement, you just do your cross multiplying, meaning the R is equal to V dt. So meaning when you integrate on both sides, you'll get your R equals to the integral of V dt. So now this is how we obtain displacement. So when you are moving from acceleration, you want to, either for you to get velocity, integrate acceleration. In order for you to obtain displacement, integrate the other. Hope that is very fine. And now if you are doing physics, now some of these things should be very common to you. That this velocity means the change at which displacement changes with time. So change, I can use D. So I can say V is the change in the displacement with time. That is what we call velocity. That acceleration is the change in velocity to change in time. So these ones are going to be the common formulas that we are going to be using in order for us to do anything concerning vector calculus. What else is very common when it comes to these numbers? For these numbers, you need to know how to integrate, and always do not forget that whenever they give you position vector, you must be able. So at times they may ask you to find a force. You need to remember that force is given by mass times acceleration. So like for that particular number, you will need to know how to make A the subject that A is given by force out of M. And don't forget units, that velocity is given in meters per second. That when it comes to displacement is given in meters. So don't forget those units, because they are going to be very crucial at the end. Because this is mechanics, units are very important. And when you obtain your answer, feel free to put a big bracket to show that those units are for everything you have obtained. When they ask you for velocity, please do not forget that velocity, you can leave, in case it is I, J, and K, leave it in a vector format, because that is a vector. Do not go, don't ignore. When they ask for speed, you know that velocity, to obtain speed will always be the magnitude, or what you call the magnitude of velocity. When they ask for displacement, for distance is the magnitude of displacement. So be very, very careful. When they ask for distance, go on and get the magnitude of displacement. When they ask for speed, go on and get the magnitude of velocity. Don't just stop at the vector format and think you have completed the question. So for 3, you may not be able to obtain, being that distance being a scalar quantity, you only obtain the magnitude. There is no need for you to get the direction. Speed is a scalar quantity. There is no need for you to get the direction. So you only stop at obtaining the magnitude, then you don't need to proceed to obtain the other. So that's how we obtain. And those are the only 3 important formulas you need to do. In case they ask for work, you need to know that work is given by the force and then the displacement, meaning that you must have your force and you must have the displacement. So and when you look at those seminar questions, you look at the end, we have summarized for you all the important formulas you need to know when it comes to it. At times they may ask you to calculate force, they may ask you for power, they may ask for work done, they may ask for impulse, they may ask for momentum. So you need to know how to deal with them. And these are the formulas that I want you to be having. That when they ask for this, this is how I find it. In case they ask for this, this is how I'm going to find it. So they are going to be very important. And these are the different units that you have to write at the end of the day. Let me hope everyone now we are on the same page. Okay. I think that is very fine. Thank you so much. Yes, Itula, you have a question? Yes, Itula?
Yeah, sir, I would like you to briefly clarify me. I think I did not get what you were trying to say. Like if you're getting the speed, is it the magnitude of the velocity?
Yes. Now, you know very well that velocity, let me say you have remained with your answer as this. So when they ask to obtain speed being a scalar quantity, it means you are going to obtain the magnitude of velocity. So magnitude means you are going to come, get the x squared, get the y squared. So for this case, it will be the magnitude of 3 squared plus 4 squared, which will give you a 9 plus 16, which gives us root of 25, which is equal to 5.
Then that distance is the velocity of displacement, right?
Yes, in case this displacement, you have remained with your answer, you have calculated, you have got your displacement as this, then go on to obtain the distance. Distance is a scalar quantity. So go on and say x squared plus y squared plus z squared, and then you continue.
All right, thank you so much.
Okay. Yes, Mwalim Fred, you can go on and throw more light.
Thank you, Mr. Kaziba, for that summary. Yeah, I would also like to appreciate the presenter. She went on very well on that number involving vectors. I just wanted to note that if we're using vectors, then the vector symbols must be used at every level. Like she was using at some points, then somewhere abandoning. It is not only for I, J, K. If you are writing force F, is equals MA, where our acceleration is in vector form. It means this letter F should be also written as a vector, that is writing capital F, then with the wave line below. When we are typing in question banks and textbooks, it is always bolded. But for us, when we are writing, let's just put that wave line below. Sometimes they put the arrow above, but the wave line below is much easier. If you are writing, say, acceleration, A is equals, and the other side is IJK form, even this small a on the left, we should indicate with a wave line to show that it's not just a letter A, but a vector A when it comes to such specifics. Then, this is a common mistake when we are finding the constant after integrating that constant of integration before finding what it is. So when you integrate, like in that case, you have integrated your expression of velocity, of acceleration to get velocity. And maybe there's a C you added on the other right-hand side as a constant of integration. That C is also a vector. At the end of it, you try to bring it about, but not so clearly. You put it in coordinate form. That C is a vector, therefore indicate a wave line. Then you say the body was at rest, which means the initial velocity was 0. But remember, we are using vectors. We are using vectors. So as Mr.
Mwalimu Fred, you are muted. No. Okay, I don't know. Mwalimu Fred is muted, but still. Okay, Mwalimu Fred is muted. Okay. Yes. But let me ask, Nyamukikika High School. Kindly unmute. Oh. Okay. Okay. Nyamukika, we have failed to get you, but someone was asking for the table, which had the summary. That table is on your seminar questions. So it was indicated there to help you summarize well.
Yes, Mr. Gazi.
Yes, you were saying something.
Yeah, I don't know whether you had muted me, but I was saying, since we're using vectors, even when they say the body was at rest, which means the initial velocity was 0. But if you write just 0, that is a magnitude. So since we're using IJK form, then even our velocity should be in vector form. That is 0, 0, 0 if it is in 3 dimension, maybe in column form. Yeah, that is a coordinate still. We have to put it in vector form.
Oh, I don't know. I'm losing out on Mwalimu Fred. Yeah, but what is emphasizing is that follow the vectors in case they are you are dealing with vectors, let it be in the vector form. Okay, so let me just pick a few more questions from the chat. Okay, I think we are going to end here on this particular number, and I want us to have just one more presentation. Any school that wants to be the last. Nyalukika. Okay, Archbishop, I think your network is okay.
I think we can complete from where we had stopped.
Okay. Complete?
Yes, let's share the screen.
I share?
Yeah, we are sharing our screen.
As I said, I'm taking you through number 108. Part 1 was saying be or has. As the formula is written, those formulas were no B occurs in case the probability of A complement union B complement is equal to 1 minus probability of A intersection B. This one is a long route. I opted for the second formula. And from the question, we were given probability of A given B. From this, it's written as probability of A intersection B over probability of B, of which this is 100, 1 over 5 is equal to probability of A intersection B over a third. Now, if I multiply, I'm able to find the probability of A intersection B, which is 1 over 15. I come back and I substitute 1 minus 1 over 15, I get 14 over 15 as probability of A intersection union B complement, which was the first question. The second question was, question 2 was asking, find the probability that event B does not happen if A has occurred. Yeah. That is the conditional probability that it is probability of B complement given A, which is probability of A intersection B complement over probability of A. To get probability of A intersection B complement, I go back to the contingency table and I say probability of A minus probability of A intersection B. And I come back, I have probability of A as 8 over 15 minus 1 over 15 over 8 over 15, which gives me the final answer as 7 over 8. Was asking us the probability that both events occur. The intersection was already calculated from here. here. That's why I just wrote the answer as 1 over 15 because I had calculated it before. Then the last question was probability that only one of the two events occur. Probability that one of the two events occur is the probability of A complement intersection B plus the probability of A intersection B complement, which from the contingency table, we get it from subtracting the probability of B minus the probability of A intersection B plus the probability of A minus the probability of A intersection B. Then from here, I get 4 over 15 plus this is 7. 7 over 15, which gives me 11 over 15. That's all that I had.
Okay, thank you so much. Okay,
All right.
thank you. Okay. Okay, thank you so much for that presentation on probabilities. Dear students, make sure you understand very well the different events. Make sure you know how to use that contiguous table. In case the contiguous table maybe is a bit tricky for you, then kindly go on and use the Venn diagrams. But also I will request that in case you are going to use the contiguous table, feel free to write it in a much better way by clearly demonstrating that you are dealing with probabilities instead of you just putting the events A and B. So instead of putting the events A and B only, please, you can go on and indicate that this is probability of A intersection B, probability of A complement intersection B. So like the way you are seeing that contiguous table, you can clearly show that this is event A, B. But what I have, where she has written A intersection B, you can put it like probability A intersection B. Then you put probability of A complement intersection B. I don't know whether you are understanding. I don't know whether Archbishop, it is easy for you to annotate in the contiguous table. Instead of you just saying A intersection B complement, it would be better you say probability, then you put open brackets, A intersection B. Then probability of A complement intersection B. Otherwise, I want to thank you so much for the great work. But also, dear students, do not forget De Morgan's rule, because when you look at the second step here, neither A nor B, you can really notice that she applied the De Morgan's rule. So it is very key for you to remember those rules when you are dealing with probabilities. Otherwise, I want to thank you so much. I think let me just write something concerning the De Morgan's rule a bit, but please make sure you apply them very, very well. Otherwise, I want to thank everyone that has joined. Okay. Okay, someone wants more clarification on number 77. Okay, let me just share. Allow me to share my screen. Okay, and I throw a bit of more light. Now, like I've said, what I was saying about the contiguous table, I was saying that when you are drawing your contiguous table, in case this is your event A and this is A prime, this is B and this is B prime, you can draw it very well and say this is probability of A intersection B. This is a probability of A complement intersection B. Then at the end of this side, you know that this is where you have your sum. And if here you have your sum, it means that this will be probability. Now for this case, this will be probability of B. Then here you say probability of A intersection of B complement, probability of A complement intersection B complement, and here you'll have probability of B complement. Then down here, you're going to have probability of A. Here, you're going to have probability of A complement. And then at the end of the day, here you are going to have your 1, such that when you add probability of B plus probability of B complement is 1, probability of A plus probability of A complement is 1. But still, please do not forget the De Morgan's rule, where when you find A complement intersection B complement, this is the same thing as saying probability of A intersection B complement. In case you find probability of A complement intersection B complement, then it means this is probability of A union B everything complement. And therefore, do not forget from here that probability of A complement can be the same as 1 minus probability of A. So in case you find yourself having A intersection B complement, it means the same as 1 minus probability of A intersection B. So this one is very crucial whenever it comes to that part. And don't forget, the moment you find the word all will stand for union. So when they say probability of A all B, it means they are meaning A union B. When you find probability of A and B, then it means A intersection B. So please make sure you pay attention to that. Then when it comes to number 77, someone wanted more clarification. So we say that when you look at these forces, you can note that along the X and Y, like teacher Naboy emphasized it very well, it is always better that you consider the forces along the horizontal. Now for this case, since here you have 90, this will be 30. For this one, here you have 45. For this one, since this is 8 and all of this is 90, it means that this one will be 10. And here it is very okay. So when you are resolving this along the X, like we said that let us take that along the X, I will use cos. So this one will be 7 cos of 30. And then note the direction, that your direction is the positive. When I resolve this one upwards, this one will be 7 sine of 30. When I come to the 5 one, when I resolve it here, you'll notice that the force is going to be pointing here the moment it reaches the x-axis. So meaning that here you'll have 5 cos of 45. But since it is pointing in this direction is negative. So when you have your Cartesian plane, this is positive, negative, and this is negative. And yesterday, Fato you attended, they told us very well that this is like the reference axis. That so negative, it will be pointing to the west. So west is negative, east is positive, north is positive, and south is considered to be negative. Then when you resolve it vertically, it means that your arrow is going to be pointing upwards. So you'll have 5 sine of 45. When it comes to this 4 Newton, still when you resolve it like this, it's going to be pointing this side, meaning that for it, you'll have negative of 4 cos of 10. Then when you resolve it vertically, since it's going to be pointing downwards, it's going to be negative 4 sine of 10. When you look at the 2 Newton force, I resolve it like this. So it's going to be pointing this side. So it will be 2 cos of 70. When I resolve it vertically, since it's going to be pointing downwards, for it is going to be 2 negative sine of 70. So we are saying that for vertical, you can use only sine. For horizontal, use cos. And therefore, when you are putting them into vector form, along the horizontal, you have 7 cos of 30. Another one you have plus 2 cos of 70, plus you have another one here, which is negative 5 cos 45. You have negative 4 cos of 10. Add all of them. Then vertically, then use the 7 sine 30, add on to this one, plus this one, plus this one. So let me hope the person who asked at least have. Okay, let me hope the person.
Yes, excuse me, sir.
Yes.
Yeah, I would like you to clarify me, like if I want to use 60, the angle at 60, yeah, and I'm resolving it to the y-axis.
Okay, 60. When you want to use this angle?
Yeah. When I want to use 60 instead of 30.
Okay, now instead, if at all you want to use 60, it means you write 7 cos.
All right.
Of 60.
Thank you so much.
Okay. So 7 cos of 60 is the same as 7 sine of 30. Okay. Okay. Hope Itula, that is okay. Then I wanted to find out the person who was Samsung. Ask. Okay, Samsung, I think you are failing to ask. Okay, let me hope the person who asked Macho, hope it is okay.
Sir, like on that very question, if you're getting the direction, like instead of you like saying the resultant is this to the horizontal, then what if me I represent it in the form of like a parallelogram? Like if I've gotten the forces on the horizontal and the forces on the what? On the vertical.
Okay. Are you seeing, what are you seeing on my screen now?
Yes.
What are you seeing on my screen?
Like, for example, if let us take, for example, like you've gotten when it's like that, for example, the resultant. And you decide to draw it in the what? You represent it on the Cartesian.
Okay. Are you seeing what are you seeing on my screen? Are you seeing 3, -4?
Yes.
Okay, let me explain using this. Now, when you look at this, in case you can write it like that, or someone else can write it like this. Now, in case I'm representing, I want to get the resultant. What does it mean? We know very well that when I come to the Cartesian plane, this is my I and this is my J. This is positive, this is positive, this is negative, and this is negative. So when I have 3I minus 4J, it means that I'm going to move 3 steps along the X or along the I. So I'll move 1, let me say this is 1 step, I move the second, I move the third. So it means that these are going to be my 3 steps. However, where I stop is where I'm going to start from. So these are the 3 steps I've moved, meaning that I'm going to move 4 steps along the J. But since it is negative, I'm going to move downwards. So I'll move 1 step, 2 steps, 3 steps, and then the 4 steps. So this is where I'm going to stop, and I'll put my direction like that. Now, the resultant means that thing that will join from the starting to the finishing point. So this is what we call the resultant. So the angle it makes with one of the forces, this angle it makes is going to be my direction. So here I'll have 3, here I'll have 4. Meaning that to get this angle, I'll have to say tan of theta is equal to opposite out of. So it will be 4 divided by 3, and arctan of that is going to be 53.1. Meaning that my tan will be 53.13 degrees. Now, for such a case, I have 2 ways I can state it. I can say that the resultant force is 5 newtons and makes an angle of 53.13 degrees or 51.3 degrees with the 3 Newton force. That is one conclusion. You can say that the resultant force is the magnitude of the resultant force is 5 newtons and makes an angle of 53.13 degrees with the 3 Newton force. Because this is the 3 Newton force and the 53.1 is here. Alternatively, you can say is that the magnitude of the resultant force is 5 newtons and it is 5 newtons in the direction of 53.1. But when you look at our axis, like here, this is the positive x-axis and this is the negative x-axis. So since our plane is along here, and this is where 53.13 is, I can say it is 5 newtons. This magnitude is 5 newtons below the positive horizontal. So that is the second way you can state your conclusion. So in case you find that you have maybe -3 and -4, and this is what you remained with. In case it was in vectors, you remained with something like this. It means I'm going to move 3 steps to the left. So I'll move 1, 2, 3. So your direction is going to be like this. So where I stop is where I'm going to start from 1, 2, 3, and 4. So my direction will be like that. So your sketch will be like this, and it will be down like this. Then when I reach here, I join the point I started from up to where now I am, like this. So now that is my result. So I'll get this angle. So this will be 4 and this will be 3. So I'll get my angle as 53.1. So now at this point here, I will say that my angle, my resultant, the magnitude of the resultant is 5 newtons, and I can say below the negative horizontal. Or I can say 53.1 with a 3 Newton force. Another person can as well go on, but this one is a bit trick, whereby, remember when we are measuring angle, always we measure them from the positive x-axis. So someone can as well set that angle, but that one is a bit tricky. But that one is found in advanced textbooks talking about mechanics. Okay.
Thank you.
Okay. Is it fine or not yet?
Yeah, it's fine. Thank you, sir.
Okay. Yetula SS.
Yes, all right, sir. I think would you please draw for me the other table, the previous question where you saw something. I want to ask a question there.
Which table?
The question where I demonstrated, where I first raised the first question.
Where? Here?
Yeah, there. Okay, now on our axis X, would it be like when would they define like any value like 7 Newton on the X? And what will happen if in case there's 7 Newton on our X axis horizontal?
If what will happen in case here.
Yeah.
Okay. Now, in case this here, this one, there is no need for you to resolve because the angle is 0.
Okay.
So you just consider that this one has the x. In case you are writing it in vector form, it means that here the x is already what? Is 7. There's nothing like resolving, and the y is 0.
Okay, thank you.
Okay. Okay. So if you want to put to say that it is you want to write cos, then here since the angle is 0, you can just say 7 cos of 0, 7 sine of 0. But still you remain that 7 cos 0 is 7, 7 sine 0 is 0. In case you want to maintain the uniformity. Okay. Okay. I think this is very okay. Now, what are we going to do, dear students? Your task is now to complete all these questions. And then we see how we can better our source. But before we conclude, let me ask Mwalimu Fred.
Yes, please.
Yes, can you give some concluding remarks to the candidates?
Thank you very much, Mr. Kaziba, for your time and for organizing all this and for always supplementing well on most of those questions. I do not have so much to say because I've already spoken, but I think my observation yesterday, you can see it today, that paper 2, we still have many challenges, so many questions, so many misconceptions here and there. So it is through such interactions that we can share and our learners will eventually be there. And as I said, you see mechanics, even what we consider to be obvious is not what? Obvious. But through sharing, I think we shall eventually be there. I think that is what I can say. We just encourage the learners or our students to continue going through those questions. They were very well selected questions. So if a candidate can go through all of them as an individual or through discussions, through consultations with the teachers in their schools, by November, I believe they will be good enough to write their exams and pass. I wish everyone here success, and we thank you, the organizers of helpline seminar. Let us continue like that. Thank you. I remain Nambo Fred, a teacher at Mbale, SS.
Thank you so much, Walim. Someone who wanted clarification on number 107. 107, I think we did a similar number yesterday, and Mwalim Fred talked about a lot about the range of the middle 40%. So I'm going to ask you if you can, I think it was towards the end, but in case it is about rank correlation between those two subjects, when you are commenting on the results, since they have specified at 1%, refer to your logbook, look out for now for this particular one. We had about 9 of them. So you look out for the num n when it is 9, and look out at the significance when it is at 1. Then look at the coefficient you have obtained, and then you comment accordingly. But I think we are going to have some of those questions answered when it comes to this week. So dear students, this week, we are going to start our facilitation. We are going to run the facilitations for 2 consecutive weeks, this week and then the coming week. And in those 2 weeks, we are going to be concentrating on particular things. Now, like take an example, starting tomorrow, it's going to be Monday, but these facilitations are going to be happening at 4, starting from 4 to 6. So meaning that you must now plan well. But being a candidate, it is this time that you need to sacrifice part of your enjoyment time and dedicate this time to enjoy in the future. So I would request you that now take off some time. I know at around 4, 6, you're already having sports and other activities, but it is time now to sacrifice such that you can enjoy in the future. Sacrifice now such that you can have a better future. So at 4, starting tomorrow, we shall start with ICT. And so anyone doing ICT, tomorrow you can connect. In case you have any questions about ICT practicals, many tomorrow we shall be dealing with ICT practicals. In case you have any questions, it is that compile them, and then tomorrow feel free to ask. Then on Tuesday, we are going mainly to specifically look at applied mathematics. And in that session, we shall dwell more on the projectiles and probability. But we shall give you sample questions, and in case you have any questions about applied mathematics, it will be Tuesday. Wednesday, for those who are doing entrepreneurship. Thursday, we shall deal with pure mathematics, and then Friday, we shall deal with chemistry. Then the other coming week, we shall bring in the biology, we shall bring in the physics, we shall bring in economics, and then other subjects. So this is going to be our program. So next week, we shall not have any of these subjects again, but we shall have other subjects come on board. So kindly prepare early enough such that tomorrow you don't miss. In case you have any concerns, any questions, and the rest of that, please prepare them for tomorrow in case they are for ICT. We are going to use the same meeting room. So this is the same room that we shall be using tomorrow. So don't not look for any other room. We shall be in the same room again for tomorrow. So nothing is going to change. You'll just log in the same way you logged in at 4 to 6. But we want to thank you. We want to thank you so much for sacrificing this time. We are really very grateful, and we are always praying for you that all your sacrifices, all that time you are putting in, that the Almighty God may reward you abundantly. So we are praying that for all those who are sacrificing, that all these efforts you are putting in, let the God reward you accordingly. At the moment, I know you are trying your best. I know you may not be able to see the results, but I want to let you know is that at the end of the day, those results will be seen. Those people who know fruits or who know these trees, the last thing always to be seen is the fruit. So you may put in a lot of efforts and you are not seeing the fruit at the moment, the results. But I want to let you know that all these efforts are going to pay off at the right time, and you'll be able to touch on those different fruits. that you are yearning for. And we want to see that each one of you at least goes out with an A. We want to thank the teachers. Thank you so much. The school administrators, thank you so much for sparing time and connecting the students online. We are really very grateful. Yes, Mwalimu Fred, you have something before we close?
No.
Okay.
No, sir.
Okay. Thank you so much. Let us meet tomorrow for another session for in ICT. Thank you so much, Mwalimu Fred, for always being on, for always putting in a lot of emphasis, for always sharing with us. We are really very grateful, and I know you are going to be very resourceful in our coming session. Thank you so much. We appreciate a lot, and please send our greetings to Mbale SS when you get there.
You're welcome. We appreciate it.
Okay, so we are going to end here, everyone, and we want to wish you a good evening. Teachers, you may take for us some photos in the dark. I'm seeing some darkness already coming in for those students. Let's meet again. We wish you all the best. Bye-bye, everyone.